watch the star party, but more like breaking down different subjects like engineering and engineering, astronomy, and other things like that for kids my age.
Well, it's good to see you back, Libby.
It's good to see everybody. I miss them. I was telling all my friends at space camp, I was like, I have so many fun astronomy friends. I mean, I was like, a lot of them aren't my age. You just love to talk to them because I never really get a lot of kids in my area who are interested. So,
well, we might not be your age, but we're all kids at heart. We're all
yeah.
children of the earth.
You got that right, Cameron.
Age doesn't matter, but I know I still want to get kids interested because it's important, because there won't be NASA. There's no kids, or because kids turn into adults and there's no kids to run it or anything, because there's nobody to even run NASA. So we have to carry the torch. So it's like there will be no NASA, and then we won't really be able to get anywhere in the universe. And especially for the people who want to get somewhere in the universe, it's not as fun, but you just have to ignite passion and let everybody know what is out there in the universe.
Yeah, it's all about planting the seed and awareness, and that's great. That's great, Libby. Doing great.
Well, we are having probably one of the best summer storm seasons we've had in decades. It is just coming down. We just had a rain of about at least 1/10 of an inch. And over the weekend, since our last global star party, we have had almost 5 inches of rain. It just comes down in buckets. And
wow,
we really need it, and we love it.
Yeah, that's rain. Water is life. I mean, it's one of the key ingredients. And I think last week was the doctor. I forgot his last name. Professor Abel. Anyhow, he was talking about the ingredients for life. Right? You need earth. You need a solid. You need some gas. And you need water in liquid form, and then what was the other one? Energy, of course. Yeah.
And just now I saw greeting me was a lovely little gopher snake, and right in front of our house. And he said, "It's wet out here," and I said, "Yes, it is. Can I join the global star party tonight?" And I said, "Well, I'd like to let you, but I don't think so. It would be a little difficult. I mean, I could hold you with tongs or something, but I think that would be kind of interesting if you were to talk about a serpentine view of the stars, but probably not tonight."
Good try. You had the right intention.
Yeah. Hello, Jerry. It's
hey,
good to see you.
Hi, David. How are you?
Oh, pretty well, thank you.
Good. I'm changing my moniker.
Jerry Hubbell is a very well-known part of Explore Scientific, and he is also on the editing board over at Springer, and we're really honored to have him here today.
Thanks. Thank you, David. Trying to get the observatory up and running. I had some few issues with my internet here a few minutes ago. I restarted my router and got it all back.
Jerry did a great show earlier today on photometry.
Oh, thank you.
That was awesome, Jerry. Thanks.
Thank
Good
you.
stuff.
Good night, everyone. Today I enjoyed the photometry. Of course, that I copy every link that you
Cesar.
post. Hi, Cameron. How are you?
Hey, good. How are you? Awesome.
And today was an excellent show of about photometry, and I've not tried yet to change some file from CR2 or raw files from the DSLR cameras. It's really nice because it's something that when the amateur astronomers looks some worried about take pictures, it's great to put them to make some science, starting to start to take photometric measurements of stars. It's really great. It's really helping for maybe they can start to found asteroids, or observing the rotation of the asteroids, taking the photometric values. It's great because when you have the curve of light of an asteroid, and maybe with a 6 inches telescope, many amateur astronomers don't know that they can do it. They can take measures, photometric measures of an asteroid, get the data to know the shape in the rotation. It's incredible.
That's a good comment, Cesar. It's good to see you here. I did want to show you a copy of one of my Springer books. This is one that came out a few years ago, one of my more academic publishings, and just wanted to show you the cover of it.
That's nice.
Oh yeah.
Nice. Yeah.
Oh, very nice.
Those were the days when I knew how to write.
I'm sure you still know how to write.
Still know how to write.
Yeah.
You may not want to as much, but again,
I return later because I have a work in 10 minutes more to get support to customers to start to use astrophotography, and it's with the EXS 100. And
yeah,
I'll disconnect and connecting later again. But I like it started with the growth in the early connection and the early login.
Right on. Good
Yeah.
luck, Cesar. Good stuff. Look forward to seeing you later, man.
Yes. Okay. I return late. Bye bye.
All right, Cesar. Bye bye.
Bye bye.
I relate writing a book to eating an elephant.
Eating an elephant.
Yeah, you're right. It's the same process.
Yeah, bit by bit.
It's one bite at a time. You just have
Yeah.
to work through it.
Yeah, that's true.
I've
But you
never
have
eaten an
to have a roadmap. It's good to spend a month or two just working on the outline for the book and identify every chapter and every section in each chapter. Kind of like writing a program in a way also.
We're going to find out tonight if we have a place in the universe.
Yes.
I don't know if you're
that quote. I like that quote. You and I have as much connection you and I are all as much continuous with the physical universe as a wave is continuous with the ocean.
Mhm.
I like that.
I do too.
Yeah, nice quote.
I don't know if you ever watched Lewis Black. He's a comedian. He had a bit about Starbucks in the center of the universe.
Starbucks in the center.
Yeah, so he was in New York or something. I guess he was in New York, and he faced the Starbucks on the corner, and he turned around, and there was a Starbucks on the opposite corner. He said he reached the center of the universe.
Right there. All right. Just don't get sucked down a black hole.
So he knew his place in the universe at Starbucks.
You got to start somewhere. Okay, I think everybody's ready to get started. What do you think?
I think we're just
You
about
bet.
ready.
Yeah,
Just deep breaths and lifting weights and
lifting some weights, doing some push-ups.
I'm
Plank.
really enjoying the Olympics. I am.
Yeah. Okay, I think we will get started then. Here we go. Well, hello, everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance. And tonight we are celebrating the 56th Global Star Party. And we have regulars that have not been around for a while because of other activities they were involved with, but many of them are here tonight. Including, of course, David Levy's always here with us, but we've got David Eicher, who's returned after, I think he was at Space Fest and a couple of other things as well. And we have Rodrigo Zelada, who is studying, and I'm not sure if he's already involved with a professional research team right now, but he's kind of crossing that bridge from amateur to professional. He's going to be back on the show tonight, which is totally cool. Libby in the stars, she was at Space Camp, and so that I know she had a lot of fun with that. And it was a great experience for her. And we have other people on tonight as well. Chuck Allen from the Astronomical League, Deepti Gautam from Nepal. Conal Richards will be on with us later in this segment. And then, of course, we have the contingent from South America. We've got Cesar, Brollo, Maxi, Falieres, and, of course, Rodrigo, as I mentioned earlier. And then we will have Pekka Hautala will be coming on. Gillis is on with us. Adrian Bradley. So it should be a great night of astronomy and lectures, and Jerry Hubbell will, hopefully he's got some clear skies. We can get some live views through the Mark Slade Remote Observatory. So I will get started first by introducing my dear friend, David Levy. David is in Arizona. They have been swamped with water because of the monsoon. But I think that Arizona, as dry as it can be sometimes, you can certainly use the water. So, but David, it's great to have you on all of our star parties. I was sitting back today thinking about things like the Great Conjunction and some of the other events that we did together just in this. It's been almost a year. August 4th, this summer will be one whole year of global star parties, and we're already past our 56th one. So at times we did more than one a week. We were doing a couple a week at some points. So, but there's so much going on in the sky. So much to talk about, and for me, it's kind of evergreen, and people like the people I'm with tonight, inspire me, and they keep me going, and I know they keep you going too. And so we'll turn this over to David Levy now, and thanks for doing all that you've done for us, David.
Thank you, Scott. And it's really wonderful out here. Between the last Global Star Party and tonight's Global Star Party, our home has seen over 5 inches of rain. It has just been coming down in buckets.
Wow.
It's almost like God has knocked on the door and said, more water. And the last 1/10 of an inch has happened within the last 25 minutes. And we are just so pleased. Our desert is turning so green, and we're just lovely. And I wanted to share with you that I had a conversation with one of the other species.
I think we lost David here. Let's see if he can come back on. Well, you know what? He might have had a lightning hit or something like that. That's possible. Wade Prunty says he got rained out.
Yeah.
Well, we'll come back to David if he can come back on. So that it bumps our schedule up just a little bit, but that's okay. David Eicher has spent a lot of time in Arizona recently. He was at Space Fest, hanging out with astronauts. And I think he took some time just to kind of relax and check out what Arizona has to offer. David, how you doing, man?
I'm doing well. And I was up in Flagstaff recently as well at Lowell Observatory, where there's a huge new museum project that is launching that's kind of exciting. In a few years, there'll be a $38.5 million new museum complex on Mars Hill. So that's an exciting development as well.
Wow, that's great. Is Ian McLennan and Bill Peters involved with that? Or is
Exactly. Yes, indeed, they are. They're working on that with a pal of mine named Glenn Smith as well. They're all planetarium people.
Yeah.
Yep. So they're working on that, and there's going to be, actually, not to go on and on about this, but David is almost back. But there will be an open air planetarium on the roof of this museum in which people will see the real sky and have planetarium discussions, as well as theaters inside the building. So anyway, we've got David back.
Okay, that's great. That's great.
Oh,
hey, David, you made it.
I'm back. Okay, and I'm sorry about that, but when you're dealing with technology, I was in the middle of telling you about a little serpentium that I just bumped into about half an hour ago, right outside our back door. And he said, it's raining. Can I join the global star party tonight? And I said, what would you have to offer? And he said, the little serpentium said, I look at the stars more than you do every night. I'm out looking at the stars. And in fact, I want you to show me through the telescope. And I said, I don't think I can do that very safely, but you're welcome to come in and join the global star party. So tonight it's possible that our little gopher snake will join us at the star party to tell us about his view of the night sky. Until that happens, I wish to introduce you to a very famous American writer, Ralph Waldo Emerson. When I was in college, I didn't study him that much, preferring instead his best friend, Henry David Thoreau. But he has had wonderful things to say about the stars. And I read this particular line as the introduction to one of Isaac Asimov's books. And I'd like to share that with you right now. He wrote this in 1836 in his essay on nature. To go into solitude, someone needs to retire as much from his chamber as from society. I am not solitary whilst I read and write. Nobody is with me. But if a man would be alone, let him look at the stars. The rays that come from those heavenly worlds will separate between him and what he touches. One might think that the atmosphere was made transparent with this design to give us, in the heavenly bodies, the perpetual presence of the sublime. Seen in the streets of cities, how great they are. And this is the part that really gets to me. If the stars should appear one night in 1,000 years, how would we believe and adore and preserve for many generations the remembrance of the city of God which had been shown? But every night come out these envoys of beauty and light the universe with their admonishing smile. Back to you, Scotty.
Excellent. That was beautiful. That was a beautiful poem. Great. The theme of our program tonight is, our place in the universe, and that meaning is of course different for everybody. I mean, there's a scientific meaning for it, but there is the experiential meaning of it too. What is finding your place amongst everything that's going on in your life, and for me, I think almost the moment I really got involved in astronomy, a lot of things clicked. I started to understand not only scientifically where we are in the universe. Of course, we learn more and more about that all the time. I mean, it's a scientific method, right? We used to think that the universe was a certain size and age, and now it's another size and age, and sometimes that number gets revised. And there are constant discoveries going on. David Eicher is clear to point out that we are living in a golden age of astronomy, and the dialogue that goes along with that helps us to understand our relationship with the universe and the path that we think we're taking. So today he's going to be sharing with us views through his microscope, and so I'm going to turn it over to you, David.
Thank you, Scott. And Libby, when we came on earlier, was talking a little bit about Carl Sagan, and I'm actually coincidentally doing a bit of writing right now on a project that is just starting up that ties into all this. You mentioned our place in the universe, and we've talked about what we're made out of, and that we're products of the universe, and looking microscopically at some of these minerals and meteorites and so on. And it's interesting because Carl, years ago, I was fortunate enough, one of the first times that I spent some days with Carl and around a little bit was at a meeting in, of all places, Eau Claire, Wisconsin. And it was a meeting called Comets and the Origin and Evolution of Life, which was held in 1991, which I know is unfathomably, unimaginably long ago to some of our panelists here tonight. But it was an important meeting because at the time it was very in vogue to think about comets contributing a lot of water to early Earth and also organics, of course, which they contain, small bodies in the solar system, and how that might have related to the origin of life on Earth. And so all this stuff ties together, you know, where we are in the universe. Of course, as Carl said famously in Cosmos, you know, that the carbon in apple pies and the iron in our bloodstream and so on and so forth came from stars. And so to look at these elements and how they combine these atoms in specific ways and know that the atoms in our bodies were literally made in stars for the most part is pretty neat and reflective on where we are in the universe and how we relate to it.
I'm going to interrupt you just for a second.
Yes, sir, of course.
I'm just going to say that one of the things that I brought back from Cosmos was a line that he said that I've got to repeat to you now. To create an apple pie from scratch, you must first invent the universe.
That's another, he was pretty good, wasn't he?
Oh, yeah.
And then, of course, there was Joni Mitchell, who said, you know, we're stardust, we're golden, we're billion-year-old carbon, but we need to find our way back to the garden. You know, there's that song that popularized this notion even before Cosmos as well, that Crosby, Stills, Nash, and Young had actually a sort of a bigger hit with in the public consciousness there. But, you know, as we know, we've talked about already that, and forgive my aqua blue screen, but that's the out of focus microscope I'll get to in a moment here. But we've talked already about, you know, where does the stuff of the universe, where did it come from? Because as we know early on, it was energy, and energy and mass are are exchangeable quantities of the same thing, which of course E equals mc squared tells us, c squared being a constant, the speed of light. So, you know, we can eat a cookie and run across the yard and convert that mass into energy in part. And it's amazing because now we actually know in the last decade or so, much more accurately where the elements came from and therefore where the atoms within us came from. And of course, with hydrogen and helium and a little bit of lithium, it was Big Bang nucleosynthesis very early on in the history of the universe. But as we've talked about, also many of the heavier and more important, if you will, elements came from exploding stars, either dying low mass stars, many of them, or supernovae, high mass stars that exploded catastrophically, or in the case of some of the heavier metals, things that we like for industry and jewelry and so on, including gold, silver, and platinum, from merging neutron stars that we can see occasionally in the universe as gamma ray bursts. So, you know, we're literally made of atoms that have been sent forth into the cosmos, mixed around, and eventually ended up in our bodies. Which is pretty incredible. So let's see if we can take a look at a couple of common things here. We'll start with, I don't know if you can see this here, but this is, some of it's a little shinier than other parts. This is native copper, which of course is an element and very simple stuff and largely comes from supernovae, originally the copper atoms, or exploding white dwarf stars as well at the ends of their lives. So that's ordinary, not super attractive stuff. But then if we go to copper iron sulfide, this is what mineralogists call chalcopyrite or chalcopyrite. This is, elements getting together and mixing together. And you can see there's some iridescent colors.
Wow. Beautiful.
That form from oxidation, from oxygen. Of course, oxygen really, really likes to react with everything very easily. And so this is copper iron sulfide that has been oxidized a bit too, that gives us those pretty colors too.
You can see this perfectly.
Some of the crystal. You can see it
Perfectly.
Excellent, excellent, excellent. Then some things are, as I said, are more exotic and they crystallize in different ways. Now, this is the result of neutron stars that collided. I don't know if you can see these, and we've got this microscope is quite high powered, but you can see these little wires. This is native silver. This is from Kongsberg, Norway, a famous silver locality. And you can see that silver often crystallizes in wires. And as I said, silver, gold, and platinum all originally resulted, the origin of the elements from neutron stars that collided, which gives us nice jewelry, among other things in our culture. And we can go to a really exotic, maybe. There we go. Sorry about that. Got different distances here. This is a little cube of platinum. And you can see it magnified here. It's maybe a little less than a centimeter in diameter here. And so there's a little bit of iron in this, but it's mostly platinum, which is quite a rare metal. And that, again, is the result of merging neutron stars. Then there's some really ugly stuff as well, but it's kind of neat. And I thought I'd just show this. It doesn't look like much. It's kind of a black sphere. And in a moment, I'll change cameras here and just kind of quickly, if I can, show these so you can see the whole specimen at once. But sometimes minerals come from really strange places. We think of just the areas we like to traipse around on Earth's surface here. This is a ferromanganese nodule. That's iron and manganese and a little bit of carbon and a little bit of oxygen that's from the ocean floor of the Pacific south of Hawaii. So it turns out if you get down to, the floor of the ocean and you miss all the shipwrecks, you get lots and lots of these ferromanganese nodules that are along the ocean floor that occasionally there's a submersible that goes down and fetches a few of them. They're really hard to come by and kind of ugly too. Then I thought this is really only partly a mineral, but I thought I'd show this for fun because there is we're living beings, we're sentient, we can talk as we always do about the meaning of all of this and the universe and look out and understand galaxies and so on. There's a kind of a bridge sometimes between the mineral world and the living world. And some of them actually change with each other over time intervals that we can talk about later. But this is, if I can focus it here, this is just one example here of a living being that is trapped. This is 20 million year old amber tree resin, fossilized tree resin from the Dominican Republic. And this is a Hymenoptera. This is a fossilized winged ant that's 20 million years old. So if we could get into this thing and extract the DNA, it would be in there, and that's the cracked surface there that you see of the amber that's been polished, and there's the winged ant. And we know we could not clone one and bring it back to life, a la Jurassic Park, I'm afraid. But there is 20 million year old DNA in there. So that's kind of a bridge that preserves a lot of life that we can study on Earth helped out by a little bit of mineralogy here. So now I think it's fun just to show a few of these from time to time. And if I can get back into my preferences here, and it will allow me, maybe I can quickly switch cameras and I'll just show you if this works. Can you see me?
Not yet.
No, I can see me.
You see you?
You can't see me?
I can see you now.
Yep. Yeah,
Okay.
yep.
Maybe it just took a minute. So I just wanted to show you here. I'll hold them up a little bit closely, but try to keep them in focus. This is the copper specimen on top there. You see the native bunch of copper there crystallized that I showed at first. And I thought it would be good to show this because the microscope is a pretty high magnification system. There's the chalcopyrite. Nice and iridescent oxidized colors there, from gold to kind of a nice bright purple. Then we have this little boot of silver mineral that's called a canthite, and then some white calcite. But the silver wires there are silvery colored stuff on this specimen. Well enough, and I don't want to throw the focus out here, getting too close to that camera. There's a little tiny cube, as I mentioned, on top of this mount here up on the top there, of a little tiny cube of platinum. That's, of course, quite a rare element, much rarer than gold in its native form. There are ferromanganese nodule dredged from the ocean floor. Looks like a little, clump of black tarry rock. Not too exciting visually, but it's kind of neat to know what it is. And then here is our 20 million year old winged ant that I don't know if you can see within that amber or not, but I think about as well as we can try it.
Yeah.
Here.
I think we're getting a little bit of a video freeze frame here.
Oh,
Let's see. There we go.
is that a little better?
Yes, it is.
So anyway, another little random sampling of things that the universe likes to make. And remember that there are about 7 octillion atoms in your body on average, a human being. And that's 7 billion, billion atoms. And every one of those is a product of the universe. Most of them a product of stars that lived long, long ago. So that's a pretty neat thing to remember when you're falling asleep tonight. Scott, thanks, and back to
Thank you. Thank you very much. That's great. Okay. There's such a huge difference of seeing those things under the microscope versus, especially you saw that little square of, was it platinum, right? So it was,
yeah.
And a lot of times you see these things and you don't make like the instant connection. Oh yeah, this originated from a supernova explosion or 2 neutron stars hitting against each other or something like that. That's not the immediate thing you jump to. You might look at it and go, wow, that's beautiful. Where did they find that? You're just amazed at the color or shape of it or whatever, or something you might do with it, like make jewelry out of it or something like that. But to know that it came from, the fusion furnace of a star, that exploded eons ago, is just that really bends the mind. That's for sure.
It is pretty neat. And Scott, as you said already, we only know this specifically in the last number of years that you can count on a couple or 3 hands. So we are literally living in a golden age of beginning to understand the origins of the elements, where they came from and why and how. So it's a really privileged era to be able to know that. now, which a generation ago we really didn't know with any kind of specificity, you know?
Right. That's right. Yeah. And so it just, in our generation, it's just amazing to have watched, early space explorers, not knowing, maybe hearing about the idea of a black hole, but not knowing that we have black holes. It's just been discovery after discovery after discovery. So, what a thrill it is for, I think, any astrophysicist or any scientist today in almost any discipline, because everyone's realizing it's all connected. So, which is that, and that helps to maybe put some perspective on your place in the universe. So you're connected to it all. Up next is Chuck Allen from the Astronomical League. The Astronomical League is getting ready for their virtual event, which will happen in August 19th through the 20th. Is that right? August 19th through the 21st. And it will be online and it's free. Chuck, are you with us? It does not look like Chuck's with us right now. Okay. All right. Well, I'm sure we'll catch him a little bit later then. I've noticed that we've had a little bit of internet issues here tonight. So, why don't we move on straight over to Libby in the stars?
So I'm so excited to be back because I actually just got back from space camp and I really wanted to share the experience because this is actually my second year going. So I made a presentation of all the things I did. So I really wanted to share it and share some photos, and there's even adult space camp. So it's never too late. You can go all the way till you're living, till you're almost dead, because you can go at any age. So I just wanted to share the experience. So I'm going to go ahead and start presenting my screen. So I'm going to present. So here's a picture of me and my friends chilling in an astronaut capsule. We decided to take a picture because we were all like, we found an astronaut capsule that we went inside and we took pictures. So we it was just one that you walk into and we're all looking at all the controls. So I want to talk about my journey to space camp first, because I live in Northwest Arkansas and I don't like traveling in the plane as much. I mean, right now with COVID, if there was no COVID right now, I would travel in a plane, but I love going on a good road trip, and it was 8 hours. But earlier this year, I drove 21 hours up to Key Largo and Key West from my home. So it wasn't really much of a drive since that 21-hour drive that I made all the way up to Florida earlier this year. So my journey up to space camp, we did it all in one day and a big night of rest before we checked into space camp, because that was a long, long road trip. So I want to talk about the habitats. So at space camp, you might not expect this, but they try to make it look as much like the International Space Station. So this is what inside the rooms look like. I took a picture before everybody else came in here. And so I actually stayed right kind of up above the desk. And the walls on the side of the building are curved like this. So that's what makes it look like the International Space Station. But I kind of like to refer to it looking like a cruise ship, because the place is so big and there's kids running around everywhere. And there's like all these, you get like it just looks like the inside of a cruise ship, because there's big railings and you can look over and it's just gigantic. So one of the first activities that we did was the 1/6 gravity chair. So the 1/6 gravity chair was one of my favorite things to do at space camp. I am really tall for my age, so it was really funny. I kept on jumping up, and I was jumping up so high I was surprised myself. But so they call it the 1/6 gravity chair because there's basically saying Earth's gravity is a whole, and if the moon's gravity is 1/6 of Earth's gravity. So that's what they're saying. So basically it's just a simulator of what it would be like to walk on the moon. with the gravity and everything, except you don't have any like astronaut suit. So it's kind of like that. And so one of the big things that we do during the whole entire trip is you get to do mission day. And I remember we were, you get assigned a role. And so she went around to me and she said, "Do you like explosions?" And I said, "Yeah, I do." And she said, "Well, you're gonna love your job. You're Fido." So I was in control of explosions, which I was really happy about my job this time. So I got mission control again. So you can either be an astronaut or mission control. And I was really like, I really want to be an astronaut because I was mission control last year, but I got a different job. And so it was really fun getting to do all that. And of course, I get to have the big experience again of wearing the giant headset and being able to talk through it. Because there's like 12 kids in the room. There are more kids this year, which I was really happy about. And there were like 12 kids all lined up on a big giant desk. And all of us had roles. And then everybody was just talking through the headset to the astronauts. And we had big screens like all over the walls and everything. There were like 4 TVs for a side of the room. There are like 8 TVs total in there. And you can watch the security cameras showing the other kids in the team as astronauts. So the next thing that we did during the trip was a multi-axis trainer. So this is one of my favorite things to do at space camp. So NASA, they sent up astronauts, and this was a while back, and the astronauts experienced a tumble spin. So they did not really expect to have a tumble spin. So they didn't really have any training for it, but they have to keep their consciousness. So NASA made a trainer, but then later decided to take the trainer out of astronaut training. But now Space Camp has it, and it's slightly more kid-friendly. So you're spun around in every single direction you can be, and it's just spinning you around. And you're the people who work at Space Camp, they ask you a bunch of questions, like basic questions like, what's your favorite planet? What's your favorite food? What's your favorite animal? So that was one of the most fun things of the trip. So I want to talk a little bit about mission patch. So while you're at Space Camp, you get to do a mission patch. And so this is my team's mission patch on the right here. And I actually drew the mission patch for my whole entire team because they picked me to draw it. And we decided we want a flying Tesla, the International Space Station, along with 13 stars representing everybody in our group, Mars, and like what we like to call it, the 2 potatoes, because they look like potatoes as the moons, and a capsule re-entering along with everybody's name on the side. So we actually won best mission patch, which I was really proud about because I did the mission patch. They chose one person out of the group to draw the mission patch, and that was me. So I was really happy because I got to do it all, and we won best mission patch. So we get to learn about what a mission patch does. So they basically told us, for a while, NASA didn't do mission patches. And then they started doing them because there were so many teams who did like funny mission patches, but NASA started taking them more seriously. And soon enough, once you get a graduation, you get a patch for your whole team that has everybody's last name on it that you can put on a jacket or anything. So I'm gonna get I got a couple of jacket. I'm gonna get a jacket soon to put all my patches on from Space Camp and just missions that I like. And so while you're at Space Camp, you also get to talk to an astronaut, which is a big part of the thing. So we all gather up under the gigantic Saturn V rocket inside, and we have a big screen with the astronaut over Zoom talking to us. And so he tells us a little about what we did. So we met, so we got to meet Larry DeLucas, and last year we met Hoot Gibson. So I was very excited to meet the astronaut. You don't get to talk, only a couple kids get to talk to him personally and ask questions, because there are so many kids that, you know, you can't really waste his time going through and through and through of every single kid. But I was glad a couple kids got to go. So Larry DeLucas, I'm sure a couple of you know about him, but he did crystal forming and crystal growing. So he learned about that in space. And so he tried to grow crystals in space, and he told us a lot about that. So space camp was very fun. I was really glad I got to go. I was afraid it'd be the same experience as last year. And yeah, it's the same stuff, but it's the same stuff as you do last year. But it's definitely not, it's a different experience because you meet so many more people, and all the girls who were in my cabin from this year, we still keep in touch, and all of them were so interested in space and everything. So I hope soon I can get some more girls who were in my cabin onto the star party, because I know they were also deeply interested in space. But I can't wait to go again next year. We are actually signing up again next year because I just love going, and it's a fun camp because I've gone to like a lot of outdoor camps where you're outdoors. And, I love going in the outdoors. That's one of my favorite things to do. I love astronomy. I love mountain biking. I love, I like rock climbing, all that stuff. And so I do all these activities outside, but the camps were never just really fun for me. But space camp was really fun. And I wanted to mention this to the audience, but because I mentioned this to everybody on the star party before the live broadcast started recording, but you get presentations while you're at space camp. They teach you about space and everything. And most of the presentations were just talking about engineering or NASA history or like satellites and stuff like that. None of them were really based about astronomy. But we did have one talk about astronomy, and the kid who was giving the presentation, he was about, I'd say 25. He said, okay, so does anybody know who Carl Sagan is? And I'm like jumping out of the audience, raising my hand. I'm like, I know who Carl Sagan is. And he was like, oh my gosh, you're so ahead of the crowd. He's like, how do you know? And I was like, I actually have a bunch of astronomy friends who were really good friends of Carl Sagan. And so he showed the whole crowd the Pale du Bloc video. And I remember all of my friends were just amazed by the video, and they're like, that video is so cool. I mean, you don't even have to be interested in astronomy, and that just ignited a million people's passions, because it's like the video just tells us how small we are in the universe, but yet how big we are in this world. Because you think that the Earth is just, just Earth. I mean, you just think that the universe is a size and Earth is a pretty decent size. But even look at all this research showing how small really we are, and how the universe is just infinite, and it keeps on growing at every single second. And there's just so many possibilities out there of life and so many things. And another thing I really enjoyed this year was we got to do the planetarium. So last year we didn't get to do the planetarium, but another thing that we did get to do was just sit on the floor and watch a video. So we did that, and it was still very entertaining. I thought it was really cool and fun. But while I was at space camp last year, I really wanted to see the real planetarium. This year they were lucky enough to let us into the real planetarium because COVID has gotten a little bit better for space camp, because they've been keeping the kids all social distance and stuff, and everything is done well with precautions. And we got to see the planetarium, and it was just mind-blowing. And and it was so cool because we had a live presentation, and the screen you could literally see the craters of Mars, and you could see every single bit of what the universe, almost like a simulator, what our solar system looked like, and data of what our galaxy looks like, and what scientists expect it to be. And it was just so cool and mind-blowing. And that was one of the best things that we got to do on the trip. But I really enjoyed going, and I hope I can go again next year. And I'm going to see if I can get some girls who were in my cabin from this year, and even some friends I made at space camp, if they wanted to come on, because a lot of my friends were like, "Oh my gosh, I want to come on too." And I was like, I'll see if I can connect you with my boss or anything like that, or my friends, and we'll see if you can get on the star party. Because I said we literally allow anybody on the star party. We said if you have an astronomy passion and you love to share the love of astronomy with others, you can come on. So they're like, we'd love to. So I'll have to see about that. But it was so cool getting to meet kids my age again, because I mean, like everybody, you can just have like a 10-hour conversation of how you got started into space, and you know how cool it is to think about space and all that stuff. And it was just a lot of fun to go visit. And I know I'll be going back again next year. And I know Cybella went on the week just right after me. So I hope she
Right.
had the same experience, because it was really cool and I got to do all these fun things. One of my favorite things that we did was there was 2 other girls that I met before I went to space camp. And they were all like, one girl was named Shelby and one girl was named Hannah. And we stuck together most of the time. The picture on the front of the presentation is just me, all of us just hanging out in a little astronaut capsule that we found. But I was really proud of my team this year because we actually won trivia night. And I wanted to point this out because I was like sitting and most of the questions were about NASA history. And so everybody got a chance to go up, and they almost stopped trivia right about as I was about to go. But then they said, let's just do bonus question instead. And I got the bonus question right, and I got my team a bunch of points. So I was very happy about it. So we won trivia. My whole team won trivia. We won best mission patch, and me and my friend Shelby and Hannah, we won a scavenger hunt. And we were trying to answer a question, and some dude came up to us and he said, "You know, I worked on that rover, right?" And he said, and we were like, "Wait, you worked on that rover?" And he said, "Yep, I got to ride that rover." And we are like, "On the moon?" He's like, "No." He said, "I got to practice it on Earth, and I got to build this rover for the astronauts." And we were like, "What the heck?"
That's
And then we
cool.
realized he was wearing like a scientist lab coat. He was wearing like a NASA lab coat, and we were just so thrilled. And we talked to him, and he said there's always opportunities out there for you to get a job at NASA. And he said, "I worked on that rover, I built it, and I got to test it out on Earth with NASA back in the old days." And we were like so surprised. And it was so cool that we got to talk to him. And then we suddenly realized that there were just scientists all over the museum that we didn't realize till later. But NASA had invited scientists, and you can go around and talk to them, for people working at the kids at space camp and all the workers and stuff. And it was so cool. We got to talk to all the scientists, and he told us that he used to work on the rover, and he showed it. He just took a little picture of his vest, and he said, "This is a picture of me in my 20s working on the rover." And it was just this like black and white photo of him on the rover going over a hill. And he
Right.
said, "I actually drove the rover to 11 miles per hour, even though it's not supposed to go that fast." So
Hmm.
he just pulled this black and white photo out of his vest, and we were just all amazed.
That's
But
very
it was
cool.
a really fun experience, and I hope Cybella had the same experience as me, because I know a lot of kids weren't even interested in space in the beginning, and at the end they were like, "Oh my gosh, this is amazing." So I think next year I'll have to see Cybella, and we can go in the same session, and we can request rooms and stuff like that.
I think you'll enjoy that. That's great.
One of the
It'd be
things-
great to make that connection here in Northwest Arkansas for you too. So
One of the things I would like to say, Libby, is that you are so fortunate that you had the possibility and the experience of going to space camp twice. In my generation, all I could do was watch it on television. I remember May the 5th, 1961, eating breakfast at home, and there was the rest of our family and mom at the table, and I went, a hymn, a hymn. And mom said, "Are you coughing?" And I said, "Oh, just a little bit." And Mom knew exactly what I was trying to do. And she said, maybe you should stay home from school. And I said, well, how about just for the first part of the day? And she said, yeah, for a couple of hours, you should stay home from school. After breakfast, she and I went upstairs, turned on the television, and we watched the launching of Alan Shepard into space. And I will never, ever forget that. Just want to share that with all of you. Good talk, Libby.
That's
Thank
great.
you. Soon, I hope when I go back to school, while I've been trying to start more social media sharing of like documentaries for kids my age on different subjects as in engineering and stuff like that. So I hope to get more kids interested in space, because I know it's very important to do that. I don't see a lot of kids in my area, and I think to myself, I'm like, well, I don't know what NASA workers are going to be here, because in the future, we won't have the people who work at NASA right now. It's our generation that we need to ignite the passion and tell them about all these cool rovers going to Mars. Because the way I got interested in the space was like just outreach. And I want to, that was Scott's outreach. It was downtown at the square, and he had his telescope out, and he was showing the moon eclipse, and I was just amazed. And for like the next 3 years, I was amazed by space. And then for a while, then we went into the telescope shop, because I've been wanting to go there. My mom was like, people say it's a really nice shop, you know, and I was like, I want a telescope too. So it's like, I was like, it's an outreach that inspired me. So I know that inspired me. I'm this deeply inspired right now. I can inspire other kids to get into space and learn about space. And I know I'm even inspired by like weather and stuff like that. I love storm chasing. I'm not really professionally storm chasing, but it's like,
One day.
yeah, one day.
One day.
I'll just watch the clouds, and then my mom see her take the wrong turn all the way back home.
Yeah.
I'm like, no, I want to go chase it. And she's like, no, you're not ruining my car today.
Well, great. Thank you, Libby. Thank you so much.
Thank you for having me on.
I think everybody listening wishes that they could have spent a week at space camp. You know, that would have been awesome. So, and I hear it's for adults too. Is that right?
Yeah, they have like adults. You can go all the way up till you're on your golden days. You can go as long as you want. Any of y'all can go. And then I know they even have like small little activities that you can do. They have weekend space camp. And I know one of my friends, Hannah, that she's from New Jersey, and she just did a scholarship to get into space camp. So she got a free flight suit, and she just did a scholarship, and you just write like a 5-paragraph essay, and she got in. So
awesome.
I was
That's
so
great.
glad she had the opportunity to come, because she said, I'm all the way from New Jersey. I said, they gave me free space camp, a flight suit, and $500 for traveling. And one of her flights got canceled last minute, so she had to spend like a bunch of money of her $500 to get an Uber from Tennessee all the way to Huntsville, Alabama. So
Wow. Goodness.
One thing I'd like to also add is that I was showing the moon to a guy in his 30s who thought he knew everything there was to know about astronomy. And he was looking at the moon, and then he took his eye away, said, okay, what else is there? And I said, what else? And I said, when I first started looking at the moon through a telescope and following a program that the person at the Royal Astronomical Society recommended, I looked at the moon for over 3 years before I was able to identify 300 craters and 26 mountain ranges on the moon and make my own map. And if you have a second, I'd like to show you that map.
Yeah, I'd like to
Right
see it.
here.
I'd love to see it.
You'll have to say something, David, to get the camera back on you.
There. This is the map that I drew back then in the 1960s. It took me 3 years to
Oh,
draw,
wow.
and I just wanted to share that with you. I drew it myself. It was from 1960 to 1964. And I have it still now. So I just wanted to share that with you.
Should
That
make
is
a
so cool that
you
you
should make
still
a
have it.
poster of that. You should make it into a poster, David.
You
That's
should bring
probably
that
not a
up. That
bad
should be
idea.
like a Hall of Fame.
Actually, I do have a poster of it kind of here, slightly smaller version of it. And it makes the cover of my magic quotation book. And
Oh,
it's
that's
right
cool.
there. Yeah.
This glass plate that I have here is taken from Mount Wilson Observatory, and the date on this glass plate of the moon, I don't know if you can see, let me get a good angle on it here. Maybe turn around this way. That's the emulsion side. You can see the craters and all the rest of it. I think this was taken with a 100-inch telescope. There's actually some writing on the top of, in fact, it does say 100-inch on there. And there was a gentleman, name escapes me right now, that took these images of the moon with those telescopes up there. And, all these plates were sadly being thrown away, so I was gifted one of them. The moon is absolutely fascinating and endlessly, you could spend your whole life looking at it, studying it, so it's not, as I totally get what Dave was talking about. He's probably aghast, oh, okay, well, what else is there, well, this is amazing all by itself, right? So.
I had a cup that I was in the thrift store. I love going thrifting and just looking in the thrift stores for random stuff I don't even need, but I still find for a cheap price anyway and say, yeah, that's kind of cool. So I was looking in the silverware section, and I just immediately ran to this cup because it had the Apollo 14 astronauts on it. It was vintage. I've shown it off on the GSP a long, long time ago.
Yeah.
And it had all the astronauts, and it showed them walking on the moon and stuff, Apollo 14. And it was just so cool to look at it. And a couple weeks later, every single day before school, I would drink out of that cup. And then I'd wash it, and then I'd show it off to my class. I'd be like, look at this cup. Look how amazing it is. Yeah. And I found it at the thrift store for 50 cents. And one day I woke up and my dad was like, okay, so I have a little bit of bad news. He said, I accidentally dropped your cup and broke it. So I was like, well, there goes my amazing cup that I drink every day out of. And it was not only I loved it as a souvenir, but it was just a really cool cup. And he said, well, I broke it at 5 a.m., but then I went on Etsy and looked how much old vintage one would be too. And it was only $4. I said, I got that one for 50 cents. I said, the story of that one is good, but I was like, oh, well, I'll just get another one offline for $4 because that was a really cool cup I had. And I always showed it off to all my friends. And I was like, I should have not have drank out of that every single day. I should have just kept that in a safe place. Because I know to money, it doesn't sound valuable, but to me, that thing was the most valuable thing. I always kept it on my shelf in my room. I always showed it off to my friends. I was like, I don't care that it's $4 or $5. I said, I found this in a thrift store, and to think that somebody was trying to give this away, I wouldn't have. I always kept that. I would have put it in a glass box. I would have.
Right.
I was I ran to it and I immediately got it. And it was such a cool cup that I had for a while, but sadly it was glass and it broke. So
There's more on the way, I'm sure. I'm sure, Libby. Okay, so let's transition over to Conal. Conal, thanks for coming on today. Your talk is about the universe through your 6-inch telescope, correct?
Yes, that's correct. So to answer the question, what else is there? It's kind of a tricky question to answer because there is so much. But I'd like to give a little bit of a sampling tonight of some objects that I particularly enjoy studying with my telescope. Let me know if you can see and hear me all right here. I'm just going to set this up.
Yeah, we can.
All right. How is this? Good. So starting off, I wanted to share a little image of mine. This was a long exposure star trail I took in May of last year. My telescope was there. I remember, I don't know if, I think it was a neighbor's light. I was trying to observe and knock some objects off an observing list, and off to the right over here, there was an unfortunate floodlight shining into my yard. So I took the opportunity, and it turned out to be a great one, to get a beautiful image with my scope in the center, some trees in the background, and then those star trails just kind of bringing in the summer sky. But we talk a lot about our place in the universe, and it tends to be a very deep discussion. It tends to have very large numbers and figures in terms of distances, or we saw earlier 10,000 galaxies in the Hubble Deep Field. And it can all be very hard to grasp, as astonishing as it is. So I wanted to distill that down, if I may, to just a couple of objects that you could see in a modest telescope. These I can see in my 6-inch very well, but they can also be seen in smaller apertures, and give some kind of a sampling to give us a little bit more of a hands-on approach to learning about our place in the universe. So it's a list of 5 objects I have here tonight, kind of going out in distance. Starting off, we have Jupiter. And the reason I selected this object out of the different planets in the solar system is because of how much there is going on. Now, traditionally, we think of Saturn as the showstopper object in our solar system. It has those beautiful rings, the Cassini division. If you look really closely in larger apertures, you can see bands. It has a couple small moons. And as interesting as that is, Jupiter is much more accessible to smaller apertures with all of the activity it has going on. So you can see in the image I provided here, there's 4 different moons, the Galilean moons, that are all very bright, 5th and 6th magnitude approximately. There's the great red spot right there. There are red equatorial bands, and then these tan sections, they're called the polar zones that change color, and there's festoons that appear, and sometimes they appear and disappear with different seasons. So Jupiter is a very interesting and active planet to observe over smaller timescales, and you can see all of those changes in a smaller telescope. In the case of the moons, you can see them coming over the planet, and you can see their eclipse shadows projected down. I remember a couple of years ago, I saw a double eclipse with 2 of its moons, or a transit, I think that it's called, where you can see 2 shadows crossing the cloud tops at the same time. And that's a beautiful and astonishing experience that does remind you a little bit about how amazing the universe can be and how much there is going on around us, even if it seems so distant. But then speaking of distance, Jupiter averages about 5 astronomical units in its distance from Earth, and there is so much to see once we go a little bit beyond that. So moving on to an object a little bit farther from our solar system at 350 light years is a beautiful double star called Almach. Now I picked this up in my telescope just last fall. I saw it for the first time, and it's naked eye. It's about 2nd magnitude, and it's just incredibly beautiful. You have a golden central star there, the brightest companion, and then there's a bluer star, a bluish white color, separated about 10 arc seconds away. And that's not too far for a lot of telescopes. It's very easy to see. We have an image here on the right at 220 times magnification. And of course, 10 arc seconds is very manageable in a 6-inch telescope and smaller apertures as well. Now, looking at an object like this, we learn a little bit more than just what we can see in our solar system. We see 2 stars orbiting each other. We see 2 different types with the color. If we go into that a little bit more, that tells us about the temperature. It tells us about the size. And there's so much to learn extending only a couple hundred light years out of the solar system, which really is not that large. on the scale of the Milky Way and the scale of our local group of galaxies. So going over much farther from our solar system, but still within the bounds of the Milky Way, is a pair of objects in our night sky, Messier 46 and a planetary nebula, NGC 2438. Now these two objects, one is a beautiful bright open cluster that looks great in binoculars. It's 6th magnitude. And then if you look at it closer with a telescope, there's an 11.5 magnitude planetary nebula down at the bottom of this image of the cluster here. And that's a really fun object to see. It's a brighter planetary, and it's got a little bit of shading. You have all the different colors of stars. This is high up in the winter skies in Canis Major. And of course, it's really fun to look at with the two objects kind of right next to each other. But looking at the distances, we actually learned that they're not really related astronomically. They just seem to be lined up from our perspective in our solar system. So the planetary nebula and distances tend to be hard to measure for those particular objects. Some estimates put it around 3,000 light years. I saw some that were closer to about 1,500, but nonetheless, they aren't quite the 4,900 that we know the cluster sits at. So we learn a lot about these two different objects. Planetary nebulae teach us about the dying stars, the low mass stars, and then we can see all kinds of different stars, different colors, and different sizes of stars throughout their formation spans in that cluster. But going back to the theme of our place in the universe, we understand that things aren't always as they seem. So we have a nebula here superimposed on that cluster, if you will. And it may appear to the observer that they are related, that they are at the same distance and in the same area of space, but they actually are not. So there is so much to learn by looking at two objects in the same view in your eyepiece. Going farther out is really a showpiece galaxy. You can even find this in binoculars, is Messier 81, sometimes known for its companionship with Messier 82, the cigar galaxy quite nearby. This is a beautiful spiral galaxy. You can see the arms and larger apertures, but then you can also see the core and a little bit of the surroundings in a 6-inch from suburban skies that I observed from, or maybe binoculars from a more rural site. But it is just a beautiful galaxy at 12 million light years away. And as you can see, going through this list of objects, we're stepping farther and farther away from our sun and still learning. So you can see there's spiral arms coming around. Galaxy classification can get a little bit fuzzy because they can be so active and diverse. Some of them are barred spirals with the bar going straight through the center. This galaxy seems to be more of a traditional spiral with so much blending in the center and the two arms, one extending over the top and underneath in this particular image. And if you look at the size of this galaxy is not too far off from the open cluster we looked at just in the last slide. Even though the galaxy is so much larger, it's farther away, and that teaches us a little bit about positioning and how things, again, aren't always as they seem, and how much there is to learn by going in closer. Now, finally, ending our tour of a small sampling of objects in the universe is a quasar called 3C273. This was among the first discovered. In fact, it was first discovered as a radio source. If you look at the image I have on the right here, it appears quite like a star. That's why I don't have the size listed. In fact, if you were going over that field, this particular object is in Virgo, you wouldn't notice it unless you were looking for it as the object being a quasar. So it's about 13th magnitude. It is a little bit dimmer for a 6-inch telescope, but very visible in an 8-inch or maybe 10-inch Dobsonian, those larger telescopes, still very accessible to the amateur. But the most astonishing thing is, even though we can see it, it's at such a great distance compared to the other objects I've discussed. It's about 2.5 billion light years away. So when we are looking at this object, the light we're seeing left the object at about a time when the Earth was still forming. It looked very different. I don't even think life was coming around at that time. Our solar system would have looked quite different with where the planets were. The outer planets hadn't quite migrated outward yet. The moon may not have had as many craters. And that brings us back around to seeing this object. It's almost like a form of time travel. We really are looking into the past, and quite far into the past, 2.5 billion years or so. So going back to our theme of our place in the universe, there are quite a lot of objects that we can observe with just a small telescope like a 6-inch that are accessible to the amateur astronomer, and they can teach us so much about how much there is to see and where we are.
Great.
So thank you very much.
Awesome. Awesome. Conal, I think everybody
question.
usually, go ahead, David.
Okay, Conal. It's obvious from what you have shown us through your wonderful 6-inch telescope that that scope means the world and the universe to you. My
Yes, it
question
does.
is a simple one. What is its name?
That's a hard question to answer right now. I guess I've spent so much time observing, I haven't come up with a name. What would you recommend?
I think you should spend time coming up with a name that's important to you. But, you know, my belief, and I really strongly feel this way, is that telescopes are people too. And if you have a name, Conal, your telescope deserves a name too. And I'm not going to suggest one to you. I think you really need to look at your telescope and choose a name that is appropriate to it and what it has seen. My telescope, which is sitting right here, Minerva, named after the Roman goddess of wisdom, is one of my favorite telescopes. And I have used this telescope as well to look at 3C273, as I'm sure you have. And I strongly suggest that you come up with an original name for your telescope and then let us know when you've decided on that.
Thank you. I'll let you know. I like that suggestion. You know, the telescopes really do have a personality, have personalities of their own with how you use them. That's my first and only telescope, and it's shown me so much in the past 5 years. So thank you very much for that suggestion. I'll let you know what I come up with.
Please do.
And Conal, you want to keep that one. My first one of my first telescope was when I was your age, was a 6-inch Newtonian. That's a great scope, and you're going to enjoy that one. It's really nice to see what you're doing with that, and really appreciating. That's a sweet spot with aperture as well. You're getting enough detail, and it's still easy to manage. So it's really great to see you sharing that. And I just recall when I was your age, looking through that 6-inch Newtonian of myself, and it's a great scope.
Yeah, you know, if I may share a short story, when I first saw the title for this week's theme, Our Place in the Universe, I thought back to a particular moment I had looking through some planetarium software, in fact. I've read a lot of stories about people who have said they've had this one moment where they've realized how vast the universe is. And I could never really grasp that. You know, I'd go out and look at the stars and it was so beautiful, but you could never really understand it just in your own mind's eye. So I remember I was compiling a list of the objects I'd observed, the deep sky objects, and this was in Sky Safari. And the program has a feature where you can call up a list of objects, an observing list, and it'll show you all the locations of those objects with respect to the sun or the Milky Way. You have this view that you can kind of zoom in and out of. Now I had done this, I was maybe 4 years, this was maybe 4 years after I got my telescope, and I knew I'd observed so many targets and spent, you know, probably a couple hundred hours at that point, or at least dozens of hours under the stars. And I thought, wow, I wonder how much I've seen and how much of the Milky Way it's going to cover. And I plugged it in and I hit that button to call up the locations, and it shows this map of the Milky Way, and it looked like just this little neighborhood. And that's kind of when it hit me how big things could be. I'd invested so much time in observing the sky, and I wasn't disappointed by this in any way, but I'd just seen that I'd only scratched the surface with so many years or 4 years of observing. And that was a really special moment to me, understanding how small the universe could be from my perspective, but how large it actually was.
Very cool.
Yeah, layers and layers.
Yes. Yeah, it never stops, Conal. So never stops. That's the great thing about it. Well, up next here is Deepti Gautam. Those that you watch, who have watched Global Star Party regularly, have seen Deepti on many times. She's written poetry, which she's recited on this program. She always gives a great presentation, but she's also starting to write some articles about her experiences in astronomy. And so I'm going to turn it over to Deepti. Deepti, thank you for coming back onto our program. all the way from Nepal, folks.
Thank you, Scott, and hello, everyone. And today I'm talking about first of all, I'm talking about all of the theme, our place in the universe. Is hundreds years ago, the most astronomers considered the universe to be about 2,600 light years in extent and less than a billion years old, and with our solar systems near its centers. Astronomers today have seen object 13 billion light years away in a universe and 13.7 billion year old, containing hundreds of billions of galaxies, and we are located in one of those galaxies known as the Milky Way. And nothing, however, has been more revolutionary than the idea that its entire universe is in the state of constant change. As planet, star, and galaxy are born and die, this story of the life of the universe and our place in it is known as cosmic evolutions. Although the idea has roots in the 19th century and was occasionally invoked in the first half of the 20th century by astronomers such as the George L. Rahel, and it really come into its own only in the space age. And cosmic evolution has several possible outcomes, and it end point maybe planet or star and galaxy, and we observe these and I know they exist, and the result is what we might call the physical universe magnified it and of itself. And alternately, cosmic evolution may result in the profession of life, either microbiology or intelligence throughout the universe. And the outcome, the holy grail of astrobiology programs around the world, the world that will constitute a biological universe. And our third possible outcome really discussed is a universe in which cultural evolution is taken into account. There is one question: is there anything special about our place in the universe? While we don't live in a special place in the universe, but we do live in a special time in the universe. In the distant futures, million or even trillion of years from now, a galaxy will be flying away from us so quickly, and their light will never reaches us. And our place in the universe tells the story of our world, formation of the first galaxies, star formed from the great cloud and containing the primordial elements made in the first few minutes, and birth of stars, their lives, death in and supernova explosions, and formation of the solar system and its planet and many moons, life on Earth, and it needs and land and in the sea, finally exoplanets and planets that surround a distant star, and interest spread in the text are short pieces on some of those who reveal those wonder, etc. And I have one short poet like. He tried to hold water in his fist, but it only wet his sweaty palms. He then tried to hold air in his fist, and it dried his wet hand. He tried to hold fire in his empty fist, but it left him with a burning sensation. He then tried to hold sand in his fist, and it slipped, not before giving relief. He realized universe could not be held, but it could be felt and sensed. And recently, I have written one articles about my experience or my view toward the universe. Is like, as human beings, we strive to explore our existence from a tiny part of the universe named Earth. We want to see those twinkling star, moon, the sun, and learn about them. And I'm a space enthusiast, or simply astrophile as you are. All those moon, stars, and other heavenly body attract me. My heart always wants to lost in the beneath of this space. I remember the day when I was 9 years old, and all I knew was the word Jupiter, Earth, rocket, and settlement. Despite my lack of knowledge at that age, I dream of settling down there. Maybe it sounds funny, but this dream is my source of inspiration, which always motivates me to move ahead. And as being an astro enthusiast, there may be some kind of dream is our inspiration that we have created. And similarly, talking about one nightmares, I call it one of the special nightmares I have seen ever. And one night I saw a nightmare that I was in some kind of mission on along with the 5 crew members becoming astronauts. And we are going to space in a rocket which was inaugurated near my house. And rocket was advanced, which can easily be returned take off. And we moved toward the space, and unfortunately, the fuel was exhausted, and we frequently returned back. And again, next day we take off and solve the problem. And we were returning our rocket rocket was out of control, and I was in panic. And unfortunately, I wake up. And imagination has no limits, and I think many of us has imagined once and have created a wonderful in our imaginations. And that's all about me. And recently I was involved in asteroid source campaign, and recently we have got 2 provisional discovery of the asteroid. That's our achievement, and thank you.
That's awesome. Yeah, DT, I also posted the article that you were talking about right towards the end. So it's nice to read that, and it's very inspiring. You know, I have not met very many people who can say that they've had dreams about being in a spacecraft, okay, or flying into space. But I have had astronomical dreams, which I'll share sometime. But you know, there's learning about astronomy and knowing that we're looking back into time, we're seeing events in light, or anyways, events that happened long ago, and they're in the past, you know. So yet, you know, through the traveling, you know, the space time traveling of light across the universe, we get to witness that, and it's almost in some ways, when I think of it, it's almost dreamlike to me, you know. And then you compress that down to just seeing somebody across the room. You know, there's space between you and them, you know, so you're seeing them in the past as well, you know, just that long ago, but yeah, in the past. So it's and then the more that the great information is coming out about quantum physics and all the rest of it, you start to learn about you know, the fact we're not even really sitting in our chairs, we're floating above them slightly, you know. So just all these little things that are coming out of this golden age of astronomy and science, physics, you know, all of this stuff is coming about to give us discovery after discovery, you know. And it's as David Eicher pointed out, it's only been the last few decades that we've been able to understand the universe in the way that we do, you know. So, and I think that everybody realizes that you know, there's so much more to learn and so much more to be discovered. So it's exciting for young people such as yourself, you know, Libby and Conal and Deepti. You know, I think everybody that's in the audience that's a little bit older than you realizes the huge adventure you guys have waiting for you. So that's great. Well, I'm turning this over to Chuck Allen. Chuck Allen is here with us from the Astronomical League, which will be having its virtual event here coming up this August. And I will share the link with you. But the Astronomical League is, I believe, the world's largest federation of astronomy clubs. They have, I believe, coming up on 25, 30,000 members, something like that. Is that right, Chuck?
It's 19,000, but thank you.
19,000, okay. We'll bump it up.
Thank you for your optimism.
All right, 19,000, still a lot, okay? Probably if you put them all end to end, they can go back and forth to the moon, you know, no problem. But the league has been a great resource for all levels of amateur astronomers, whether you're just, I mean, frankly, just beginning to look up at the sky with your binoculars to actually doing research, you know. And if education is your passion, their educational outreach program is, second to none. They have tons of observing programs, recognition programs, and it's been run for 75 years now. Is that right?
75. Yes.
75 years. I mean, and it's an all volunteer group. So it's amazing to me that any volunteer organization could last so long. But it all starts off with a great vision and mission plan, and the league has that. I'm going to turn this over to you, Chuck. But thank you for coming on to the program. I know that you told me you're running a little bit late, which is absolutely no problem, so.
Yeah,
It's great
I
to have you.
apologize for that. I was visiting a friend whose granddaughter was in the hospital, and I lost track of time.
Oh,
So I apologize for that,
yeah,
Scott.
we're sorry that she's
Okay.
in the
No,
hospital.
everything's fine. And thank you for mentioning the convention. It's coming up on August 19th through 21st. These are afternoon and evening sessions, 3 o'clock in the afternoon. The first two sessions start in the afternoon. Then at 8 o'clock Eastern time, the two evening sessions begin on all 3 nights. Let me go ahead and share my screen, Scott.
Yep.
And I think this is the one we want. Okay, can you see that okay? Okay, here are the,
Yes.
okay, here are the dates, and we've been posting the amount of the door prizes, and every time we do, it changes. We're now over $8,000 in door prizes. We had the idea of asking our member societies to sponsor nice door prizes instead of us begging door prizes from vendors directly, and it worked out fantastically. So you don't have to be a league member, and there's no cost to register. Just go to alconvirtual.org. Right here,
Yep.
you see it. And it's also on the front page of the Astronomical League website. And sign up. All we need is an email address so we know where to notify you when you win one of these wonderful door prizes. We have incredible speakers, Dr. Jocelyn Bell Burnell, the discoverer of pulsars, coming to us from Oxford University. Dave Eicher, of course, Dr. Richard Gott at Princeton, Dr. David Levy, who's a good friend in here tonight, Kelly Beatty, David Dunham, Paul Cox with SLU, and SLU is Paul Cox is providing a free membership to one of our student registrants, and it will be one of our award winners or applicants for awards, the League's National Young Astronomer Award applicants, and also our Horkheimer applicants as well will be eligible for that. So library telescope drawing and all of our youth and adult awards will be presented during the convention. So it'll be a really fantastic event. We've added Dr. Larry Crumpler from Canada, from the Perseverance mission in New Mexico. He'll be joining us, and Dr. Chris Gaynor from Canada, an author and very, very prominent astronomer in Canada, as we round out the speakers for this event. The door prize sponsors include most notably Scott Roberts, of course, and Explore Scientific, which is providing the grand prize for this event, the Explore First Light 127 millimeter Maxi-Cassegrain telescope with twilight mount. So please join us for this convention. It'll be incredible. I'm not going to go through the solar warning again. We do this every time. Just be aware, folks, if you're new to astronomy at all and you've gotten your first telescope, be very careful. Do not try to observe the sun unless you know precisely what you're doing and you have professionally made filters that are properly installed. The damage that can be done to your retina will occur far faster than you can even register that you're seeing something too bright in the telescope. So it's a zero error activity. You must not make any mistakes with it. Okay, the answers from GSP 55 on July 20th. The question was, which of the dwarf planets is the largest in our solar system in terms of diameter? It was originally thought that Eris had that record, but after more careful measurements, it was found that Pluto still had the record by 31 miles. So Pluto is still the largest of the dwarf planets. And these are the dwarf planets. The largest of them today, Eris, very close in size to Pluto. And you can see some of the others that have been discovered since. And it was the discovery of most of these other dwarf planets that caused the change in status of Pluto when the IIU met some years ago. Answer 2, the question was the constellation Camelopardalis, like many constellations, depicts an animal. What animal is it? And it's a giraffe. It's the Latin word for giraffe, which is also similar to the Greek. Question 3 was, what organization has the final word on what names are given to lunar craters, Martian mountains, stars, and asteroids, and really everything else in the sky? And the answer is the International Astronomical Union. It's the worldwide organization for professional astronomers in the world. The correct answers from GSP 55 on July 20th were these, and they were Josh Kovac, Cameron Gillis, Andrew Corkle, Michael Overacker, Israel Monterosso, Adrian Bradley, and Beatrice Hines.
All right.
Congratulations to them.
Woo! That's
okay,
great.
Our questions for tonight, July 20th. Send your answers by email to secretary@astroleague.org, secretary@astroleague.org. There's a lizard in the sky. What constellation is it? Okay, number 2. Within the last decade, this world was found to have a reddish north pole. What world is it? There's a hint in the question. Okay, and number 3, the Apollo 12 mission landed so close to the spot of an earlier unmanned spacecraft landing, the astronauts were able to walk to it. What was the name of the unmanned spacecraft that the Apollo astronauts could walk to from the LEM? And that's the end of the questions for tonight. Please join us on September 17th for Astronomical League Live Event 9. We're skipping August, obviously, because of our convention. But on September 17th at 7 p.m., we'll be back with that, hosted right here with Scott Roberts, who always has our back. Thank you, Scott. Appreciate it.
Thank you. It's going to be a blast. I can't wait for the event to happen. I think at this point, we're going to take a 10-minute break. And then we'll be back with more speakers. So it's time to take a stretch and get some coffee, get a sandwich, and we'll see you back in just a few more minutes.
Hey, Scott.
Yeah.
Oh, you can hear me. Good.
Hello?
Yeah, it's me, Simon.
Oh, hey, Simon. How are you doing? Thanks for joining us.
I'm good. The answer to Chuck Allen's last question is the SpaceX ship.
That will be the answer in 5 years. In 5 years, that'll be the real answer.
It might seem really dark. I'm actually just hiding in my bedroom in darkness to get away from the heat. And my cat wants to join me.
I always loved putting things together and wanting to know how things worked. One Christmas, I remember my mom giving me a Barbie doll house and the dream house. They put it together that night before, I guess, and I was pretty upset that it was already put together. I wanted to do it. So that was one of the things very early on that they had a clue of maybe she wants to do something with her hands, but then it later evolved to engineering. In college, I had to work to get through college. So I would work a semester and then the following semester take the money from that to pay for that semester. And it took me a little longer to finish because of that. I didn't let it stop me. I kept going. My path to working at Goddard and the Hubbell program started with, I actually interviewed for a different company. They were not interested and forwarded my resume. And believe it or not, I'd never heard of the Hubbell project. So when I got the phone call, I was trying to figure out, well, who are these people? I didn't interview with them. I didn't give my resume to them. But I had the interview and here I am 21 years later in a career that I never even thought of. And grateful, very much grateful for. I have many favorite moments from working on the Hubbell. Outside of the engineering aspect of it, Hubbell is very much a family unit. We've grown together, we know each other's families, each other's children and spouses. It is so much of a family. Some fun moments or the best moments for me have been the service missions. And while there was a lot of planning and a lot of grueling hours involved, because of the people, it made the job so much fun and exciting. The advice I would give to young females or even just a young person in general would be to not give up. And if you have a talent that you feel, or not just a talent or a skill that you feel is a God-given thing and it is a strong desire in you to fulfill, then you'll be able to do it, regardless of what adversity or what roadblocks or challenges come your way. Don't stop, keep going, and then it will eventually happen.
Well, welcome back, everybody. Hope you enjoyed that little break there and a really interesting video there with Deneen Lewis. Just giving you some, I guess, some insights into what goes on at NASA. Up next is Jerry Hubbell. Jerry is working the Mark Slade Remote Observatory from his home, which is just a few miles away from the the distance. You told me it's like 4 miles away. Is that right,
4
Jerry?
miles as the crow flies. Yes.
Yeah.
Yep. It's right up the street, basically, and it's. I like to think it's far enough to demonstrate remoteness, but close enough to fix it if I ever need to go over there.
Right.
In the middle of a session. So I've only had to do that twice over the 5 years that we've run the observatory. So that's worked pretty well.
So, and Jerry, for people who don't know what the Mark Slade Remote Observatory is, why don't you kind of give a quick overview?
Sure. I'll let me share my screen. I'll bring up the web page just to give you an idea of what it is and show you a couple of pictures. Give me a couple of minutes here, or a couple of seconds to get this up here. All right, let's see here. So MSRO the Mark Slade Remote Observatory was built about, it's going to almost six years ago. And Dr. Myron Wasuda and myself started the project after a friend of Myron's, Mark Slade, passed away and left his estate, left his astronomy equipment. He had been planning on building an observatory and had a dome and a Meade 12-inch LX200 and some camera equipment and a lot of other things that he was gathering together to build his observatory, and he was not able to do that. So Myron decided that he was going to build it for him as his legacy. And then two years ago, or almost 3 years ago now, we formed MSRO Science, which is a nonprofit, 501c3 nonprofit that's into training, outreach, and research for amateur astronomers and professionals. We've actually had a couple of professionals contact us to provide data for them too. So we do a lot of outreach, a lot of training for high school students in the local school systems. And also people all over the world have done observations on the MSRO. And let me show you a couple of pictures, I think. Let me see here about us. So that's what this is Station 1 observatory. And it's always interesting to show people that, because they say, why do you have it up against a tree? It's because that's where the deck was. And that's where the piers were when Myron first built this deck and put some piers on there. That's where it was at. So early on, when he first built his house, the trees weren't quite as high, and he had another dome, larger dome on this structure actually, that he had removed and sold 2 or 3 years before, and then we built this. And this is Mark Slade, and that's what Dr. Wasuda looks like. And this is what the inside of the dome looks like with me in the picture. And then there's another picture of the observatory. We do have 2 other stations that we have in service. I'm using Station 1 right now, though, with it's got the Explore Scientific 165 in it. And I'd like to share that now, the desktop. I've been imaging M5, which is, let's see, there it is. Can you see that?
Yes.
So that's M5. I'll show you on the chart where it is, and you can see those trees in the that I showed you behind the observatory. That's over here actually. Let me zoom up. It's up to the north actually. There's a house, and there's other things around the perimeter when you're looking around. But let me see. I can move this chart. So this is what it looks like to the north. All right, see all this brown stuff? That's all trees. And so the sky is actually the dark and the blue that you can see there. That's all the sky we can see. But basically we can see the ecliptic very well, and then also the meridian to the south. We got good views to the south. It's just not so good to the north. Let me go back to where our target is. And
is your sky actually shrinking since you guys have built this?
Oh yeah, in the last 5 years, our tree line has gone up, right? Although we have cleared a couple of other trees that Myron has cleared from that location. Our other stations are located in the middle of his backyard, which are clear of trees, in terms of how close they are. So we got much better views from the other observatories. It's just this one is just kind of stuck here, but it's fine. We had plenty of targets to observe all year long. If we're not dealing with weather, then we have some targets that present themselves for us to image.
Hey,
And I
Jerry,
just thought I'd just grab a random object and go to it and
Pretty
and
nice
image it.
random object.
Yeah, so I've been playing around. Pekka, I had a session with Pekka on the observatory probably 2 or 3 months ago, and we talked about this concept of we're imaging, but we're doing observing with the camera. We're doing real-time observing with the camera. So we take an image, we go to the next object, we take a couple images, look at it, you know. So I'm going to take an image now and get an up-to-date image for the thing. But basically, you just stroll around the sky looking at different objects, just like you would be visually. You know, that's kind of the way when you're doing these informal type of observations. You're not there to take data. You're not there to even record, you know, save the images necessarily. You're just wanting to look and see what you can see in the image.
Mm-hmm.
So that's kind of a style of astrophotography that's
almost
easy
like
to get into.
electronically assisted astronomy.
Right. It's kind of easy to get into and to get your feet wet with stuff, you know. Just it's an augmented visual experience, basically.
I did that a lot as I went from true visual. There was a product called Revolution Imager 2 that basically that's what it was for, where it would do a quick 30-second image using whatever telescope you had. And it produced an image of something that you were looking at. So that's pretty familiar with it. It was a great way to see certain things in the night sky, especially if it was a little cloudy.
Right. So you see, I changed the stretch on this to bring out more of the stars, but I find it interesting to play with this a little bit, pull back a little bit, and see where are the brightest stars in the cluster, and you can basically zoom in and see these stars, you know, that are the brightest in the cluster, and then you can always, you know, go back and see the extent of the cluster. You know, that really gives you an idea. This is kind of interesting, this little tail right here. And then you got this little loop here kind of thing, structure with the stars. But that's kind of, and to give you an idea of what this field of view is like 1.3 degrees by about 0.9 degrees. So a full moon, you could fit 4 full moons in this image, basically, in this field of view for the camera. So
I love this EAA, Jerry. I mean, what you've done is you've just extended your toolkit from visual, right? And now you can record things. You can study the object more. You can zoom in, and you can do, without stretching, like we talked about earlier. You can do photometry. There's a lot of different things you can do now that when you be able to put this on the computer. So it really enhances the overall, you know, understanding and an appreciation of the objects you're looking at.
Right, exactly. The other thing you can do, it's a fun exercise to do, is to you know, identify the stars in the image and compare them to your star chart. So let me I'm going to zoom up on the chart, and you can see there's a wealth of stars here, just like in the cluster, or just like in the picture. But it's cool to be able to identify individual stars in this image. And
yeah, there are Cepheid variable stars in this, in M5. Our Lyra stars, I think, are in the M5.
Mm-hmm.
And over 100,000 stars.
I did want to I'm going to switch away from the observatory for a minute. I did want to bring up something on my earlier talk with on photometry. I talked about calibrating the V-band filter, and I found that chart to show, actually it's a spreadsheet that I created where I did some processing on the data, on the measurements, and I want to bring that up to show, so you have a better understanding of what I was talking about earlier today.
Uh-huh.
Hey,
so
Jerry,
basically, can you
Jerry,
see that?
real quick? Jerry?
Oh, yeah.
Can you hear me, Scott?
Yes.
Was Simon saying something? I heard something
yeah,
in the
sorry.
background.
No, it's can you guys actually hear me or am I cutting out?
You're a little bit low.
You're low. Yep.
How's this?
Way
Or is
better.
it- Okay.
Yeah, way better.
I don't know what's going on then. Real quick, Jerry, I was going to ask you, when you were showing carts to seal with the sky blocked out, I think a lot of people always ask this question is how do you get it to do that?
Oh yeah, I can talk about that. Let me talk about that in a minute after I show this chart real quick.
Sure.
So I talked earlier about how you can calibrate your filter, even with just a standard green filter, using the reference catalog stars. So this is based on the image of M67 that I showed earlier, which has a wealth of stars to be able to with good data for the different magnitudes on all the stars. And what I did is I plotted each of the catalog value of the range of stars in the catalog, and against the measured visual magnitude that I processed in the image. And so you can see there's a linear relationship between the two, okay? And you can't quite see the, let's see if I can zoom up on this a little bit. Let's see. I go to 200. I may scroll out of the way. Okay. I figured that would happen. I mean, it goes to the other. I have to scroll up a little bit to show you this other chart.
There it is.
Yep.
Almost.
Yep. So how does that look?
Yeah, that's good. Go back down just a little bit. There you go.
Yeah. So there's a line plotted across here that's a linear fit. And this is the equation I was talking about earlier, Scott. Remember I told you there was a calculation.
Okay.
That's basically a relationship between X, which is the measured value, and Y, which is the catalog value. All right. So the goal is to have a measured value, and you want to know what the catalog equivalent magnitude would be. Okay. And so you plug your measured value into X and you multiply it by this number, 0.9955, and then you add this bias value, and then that comes up with the actual equivalent catalog value. That's based on the statistics of all these stars. And what this R squared is telling you is that this linear fits to within 99.3% of the true value.
Wow, that's really great.
Okay. So that tells you that's a good calibration. And this was taken with a V-band filter on top of the one-shot color camera. Remember that was the experiment I talked about that I did a couple years ago, saying, okay, so can I really use a bend one-shot color camera to do photometry accurately with the V-band filter? And yes, you can. And this is the proof of it right here, that there's no distortion. There's no, sometimes you might have a distorted data set that's got a curve to it and it's not quite as precise, but you can see how nice and precise this is. The other thing to look at is that the precision, of course, goes up. It gets tighter. So the stars get tighter to the line down here at the brighter, visual magnitude. And it starts at visual 10th magnitude, and it goes all the way up to 18th magnitude, or 17.5. But you can see the scatter is much worse up at this end than it is down at the tight end, right, at the 11th magnitude level, which is to be expected because you got more noise in the background. You've got other things that cause this scatter. But overall, it's really a nice plot.
Yeah.
And it works good.
I have a question here. Book Davies asks, can albedo be done that way too? For example, the moon and planets.
You can measure. So when you measure an extended object in terms of brightness or magnitude, There's probably a standard data on what the area is that you measure, and you accumulate the count, the photons in those pixels, right? That's basically what you're doing with a star with the aperture, is you're summing the pixels, summing up the counts and all the pixels that are in that aperture. And you can do the same thing with an extended object like the lunar surface, maybe, where you have measured, let's say you calculate a value, you sum all the pixels in an area of, let's say it's 1 square arc minute, okay, on the moon. And then you calculate what the average is over that arc minute, a square arc minute, or maybe you say, okay, over 10 square arc seconds, this is the average magnitude or something like that. That's kind of the way it would work. It's not like a point source. It's a little different.
Right. Interesting.
Right, let me get back to Simon's question.
Yeah. Thank you, Jerry.
Yep.
And thanks for all the great stuff that the MSRO does. You might have pointed out that you can join the MSRO and take part in getting, I mean, you would be trained on how to do photometry and spectroscopy, and they've got lots of programs like that. So you can involve yourself in the practice of doing science. Once you've got the hang of it, you can take that to the next level and involve yourself in pro-am projects like what the AAS, the American Astronomical Society, is trying to develop. So you'll also find that kind of collaboration possible through probably through the Astronomical League, the ALPO, and the AAVSO. So these are just some of the organizations that really support, citizen science with the amateur astronomers.
Right. So Simon's question was, how do I set up my horizon? Basically, that's the key word. Let me zoom back out and I'll show you again the horizon line. So you can see there's this plot along the edge of the circle that shows the horizon. So the way you do that is you have, you go to setup, I think it's under observatory, and then you've got a tab that says horizon on carte de ciel. And from this, you've got you can create a file. That's this file right here. It's just a simple text file. It's got in each line, it's got two values. It's got the azimuth and the altitude, two separate values, one on each line. You can do as many as you want. We did every 30 degrees. So we start out at 0 and go down to 330. And then you have the altitude for your horizon, and that's a simple file. It's just a simple file like that. And let me just demonstrate it real quick. I'm not going to pull up the actual file, but I'll show you what it looks like here. Just so you get the idea.
So I'm assuming you're doing this with the scope active so you can actually see what's going on.
Well, so there's different ways to do it, but we actually pointed the scope and down along the horizon until we could see the tree, and that's the altitude that we measured to make the measurement. There's another way you could do it. You could stand in the observatory and use your phone as a theodolite to do the measurement for azimuth and altitude. So what you would have, like start there, you would have that, and then you maybe have 20 degrees, then you have 30 degrees, and you might have, maybe it's 15 degrees is your horizon. Then you do 60, and it might shoot up to like 40. And then 90, you might have 50, that type of thing. And then 120, you might have back down to 40. That's what the file looks like right there. It's that simple. There's no big, it's not a hard thing to create, other than to do the measurements. So that's how you create it.
All right. Well, cool. Very cool. Thank you. Okay, so up next is Adrian Bradley. Adrian has treated us to many nightscape photographs. His images of the Milky Way are mesmerizing, and but he's always looking for a new and creative way to capture the stars in the sky and the horizon, and so we always enjoy him sharing his great work with us. Adrian, I'll let you take it from here.
All right. So I recently added another screen to my setup, so I'm going to try and share it. And here we go. So what you're seeing now is actually me running a routine in Photoshop that one of the images that I've played around with doing HDR merges with. Let's so I wanted to prepare a speech because the with our topic being our place in the universe, I wanted to share a little bit, and just using this image, my view of the fact that we're on Earth, we're part of the universe. Deepti eloquently spoke on this very well, as did others. Whenever I look up, I know that the things that I see are impossibly big and may not be able to get to them. But unlike the definition of astronomy, which focuses only on the night sky and not on Earth, my photography has always been to try and merge the two, to make the two belong together. So you have detail in Milky Way shots, and you have this dot is Jupiter, this dot is Saturn here. The light cast on the night that I took this photo, the light from Jupiter cast itself on the lake. And to me, there was a bit of a connection there in that you can see the bright light, sunlight reflecting off of Jupiter is actually visible as a reflection on the lake. So my simple view of the our place in the universe is we belong, and we were discovering it. No matter how far away it is, it's something that we're able to see so long as it's not cloudy. We absolutely do belong in the picture when it comes to looking at items in space. Now, if we study just those items themselves, you can't always have a tree or a beach here when you're looking, but we do belong, and it depends on the series of photos I've taken recently. This is a simple sunset picture, the reflection of the sun showing here, but this thing is big enough to swallow 1 million Earths, and yet it's something that you could blot out because of the distance. It's so far away that you could blot it out with your thumb if you wanted to. And if you see how big, the Earth is compared to us, and then imagine 1 million of those fitting into this thing we call the sun, there are some scales that we just can't fathom in our minds. They're just really big. In fact, someone asked me if the recent flights to the suborbital flights, someone asked if they had flown past the moon, and I told them they weren't going to get there. The moon's not that close, although it looks close. And I'll even pull up an image. And this is a composite that I tried to do to show what I saw as the moon was rising. It's a little off. The moon is a little sharper. Our eyes, of course, see it contrasted perfectly. In the sky, we don't necessarily see the shadow, the light glowing as bright. That we take some liberties when we do images to try to convey the beauty of what we see with our eyes. And that's what I've decided to do with my photography, is to say what I think is beautiful, make my pictures to a point where they capture the beauty that I see just by sitting there and looking up at the night sky. And then I got a chance to do some Milky Way photography again. And this is one of my favorite places to do it, because in Michigan, we don't have many skies darker than Bortle 4. This is a Bortle 3 sky. We've had some smoke in the night sky, so we haven't been able to see the night sky as much. So just about every chance I get when the smoke clears, if there's going to be a chance to image the Milky Way, which is, Scott mentioned, it's what I love doing, just seeing that ribbon in the sky. I will image it every chance I get. And yeah, I take a couple images of it, and with some of the distortion from the lens I was using, it makes it look super big here. But it's often peaceful. Even if I can't see as much detail with my own eyes, I just know it's there, and we'll go to grab it at any point. And this time of year, Milky Way chasers, Northern Hemisphere Milky Way chasers, you're going to see a lot of the core of the Milky Way standing up like this around 11 or 12. For those of you that also like to do Milky Way photos, all of this light is there is a bright light behind this building, bright red light that you see a bright green light here. This place isn't so good for observing, but it's off of the lake, and you can take some beautiful photos off of the lake. It is a park where a lot of people go camping. The skies are dark enough to get pretty good Milky Way photos here, and it is a nice place to go out and just sit amongst the stars. So yeah, I guess my answer is what I see out in the universe from my vantage point, whether it's the sun or the moon, whatever's in the sky, it's something that I'm looking to capture. And I am always blending it with earthen things. This experiment from some years ago, this is a winter scene. You can see by the trees. Just any photo that I take, I seek to include the earth as a part of the photo. And I usually do these splits where you've got a landscape and then you've got the night sky, and the two are working together. So yeah, I guess I would summarize and just say it's, the earth is a part of the universe. The earth is hanging in space. Our definition of astronomy of all things not including the earth, I think, would need to change. I think it's all things in space. Maybe space may be the focus, but earth is a part of that. And whether you represent it with a photo of just the objects in space itself, which I know I had one of those here. If you're just doing astrophotography of things in space, those are beautiful, but there's nothing wrong with including, in fact, here's a picture here. There's nothing wrong with including the earth in any of these photos. Now, when we're shooting straight at things in space, we marvel at how they look. We enjoy seeing those, but the earth is still a part of it. And I'll leave you with the sunset here. There's nothing wrong with enjoying the beauty of our own planet with our photos. So
agreed.
So that's my presentation. Hopefully, when you're doing photography, you can get caught up with a lot of people that'll see your work and they'll say, maybe you should try it this way, or you should take your photos and add this or that. Go see some experts, talk to them, and some of that's good if there's a certain thing that you want to do, but ultimately your photos are yours and it's your goal. Whatever it is you want to do with your photography, with your art, that matters more than all of the things that have been done. It's it sets a direction. Your photography can then, it stands out only because it has your stamp of, this is what I see when I'm out there. This is what you share with the world. And it makes it your own, whether it'll win awards. I try not to worry about things like that, awards or competitions, more so than just, getting better at my craft and, trying to get what I envision when I take my shots. So that's my story, and I'm sticking with it.
You're sticking with it.
Yep.
It's a good story. It's a great story. So, okay. We had Simon Tang came tonight to visit us. And so, Simon, if you could come on with us. I know he says he just came here for support, but, he's such a great astrophotographer that we got to see a few of his images. Simon?
My solar pictures, you guys have already seen them to death, even if I only took them this morning. So that's probably not that exciting. But I will show you this one because I know Cesar should really technically be up next, and my cat is going to be screeching at me in a second because she's decided to join me, as you can hear her, and get in my way. So I'm just going to show you one that, if my cat would move, that's her
Cat Nebula.
Get your butt. So this is the Eagle Nebula. M16. I hope you guys can see this okay.
Yes,
Yes, we can.
Beautiful.
Really beautiful detail there.
This is actually part of a project that I'm working with a bunch of guys all over the world. They've nicknamed it the BAT, which stands for Big Amateur Telescope. Basically, the guy that's putting this together has a YouTube channel. He's called Astro Biscuit. And basically what really got me was the idea of what he was trying to do. How do you overcome atmospheric seeing by taking certain types of images with certain scopes in a specific way? So I joined the group, started listening into this, and one of the targets they wanted to do was M16. So I said, yeah, I'll be a part of all of this craziness. And we just basically sit there and we just take exposure after exposure after exposure, and we just send it out. And to be honest, anybody can join this. But so this is my data that I'm going to be contributing into the project, which they already have. And I actually have access to a couple of observatories. So I'm going to have 4 scopes, I think in total, all looking at the same place, doing the same thing. And the idea here is we're trying to compete with a $7 million telescope. That's the idea.
See, that's what amateur astronomers do. That's
exactly. So that's the whole point. It's so many people all over the world doing this, and it's actually really interesting. Everybody has their own little thing that they want to throw into this, but the core of it here is to get as many people as possible taking pictures of the same object with specific parameters, because we do have a set parameter to follow, because otherwise everyone's just going to do 10-minute exposures. But it's actually quite strict. So what was it? Full width, half height, maximum size, whatever that statistic was again, has to be below a certain number, which makes this incredibly hard because we're trying to get past bad seeing.
Oh, I see. So Simon, if someone wants to look into this, what website would they go to?
That's a good question. I think if you just do a web search called Astro Biscuit and connect onto his Discord, I think all of us should be able to help everybody out from there. In fact, I'm surprised you don't have a Discord yet, Scott.
We actually do, but I've not used it much.
Oh, we better get on there then.
Not used it much, yeah.
So yeah, just look for Astro Biscuit. I have no idea what the link is.
Here's his website, so I will put that link into the chat and people can go check it out. But Simon, that's a beautiful image, and something that, is so inspiring. I remember when I first saw images of this object back in maybe the 70s or 80s, I thought, oh, wow, that does really look like the Eagle, because we called it the Eagle Nebula, of course. But when Hubbell came back with Pillars of Creation, which of course is the same region, just way more cropped in. you know, it was very interesting to look at the Hubble image compared to amateur images like this one, okay? Because you can see a lot of the same features. You know, so it's amazing to think that you know, you know, a private individual with his private telescope, you know, with some great skills, can turn out such amazing stuff, you know, so
you know,
competing with the professional stuff that's out there.
You know, Scott, I honestly think that technology has now gotten to the point where it is so far ahead of itself that the real problem has become us utilizing the technology.
Oh, yeah.
Because before it was a problem with technology, and it was getting to that point, and how do we exceed it? And it's, I think in the last year, companies have just come up with such fantastic cameras, regardless of what it is. It could be a mirrorless camera, a DSLR, whatever, and these astronomy cameras. But the thing here is the technology has jumped so far forward that images like you're seeing right now, as far as I'm concerned, when I first got into this, I wasn't getting anything like this. Even if I had the same scope, but with a camera that I had from 5 years ago, it was night and day. And I think Shalindra, is it Shalindra?
Yeah.
He has my original camera that I first bought. And it's great to get him involved in it and have him have the camera so he can kind of experience where I came from. But the moment that the camera technology improved, results like this suddenly became easier and easier and easier. I mean, I'm not going to turn around and say it's a tribute to my processing skills or any of that kind of stuff. I honestly have to say that technology has far exceeded the expectations of what we think we can do. And recently, when I had a chat with somebody, they just straight up said to me that NASA doesn't actually have the time to go through and do these things. And they rely heavily on people like us to do this for them. Right. That's why they don't challenge any of us. Well, maybe the $7 million telescope thing, but that's a different story.
That's a different story. That's right. Yeah. So, you know, not only technology in itself and all kinds of things, but big data is another, you know, big conversation, because there's so much data from like sky survey instruments. I mean, the IRIS maybe I'm pronouncing it wrong, but it was the infrared observatory, astronomical observatory that was put in orbit. And they collected so much data that at the end of its run, they estimated it would take like 5 or 6 decades of scientists working on nothing but this data to, you know, to go through it all. So,
but they've made it public now, so anybody can access this now, as far as I remember.
Yeah, I mean, and citizen science programs like that are really now becoming a thing at this point. I mentioned earlier in the program that I'm on a task group with the American Astronomical Society to try to match up amateur astronomers with professional astronomers in their pro-am projects and somehow help build membership in their programs. But they are all about the science, you know, so, but they would like to they need help, you know, so
totally.
If you can get an army of amateur astronomers that know how to do it, then, you know, all the better. Well, Simon, thank you very much. Thanks for coming on. You're welcome to hang out the duration if you'd like. So,
like I said, you know what I'm like when I come on here. I just come in and just cause havoc. So you guys do your thing. I'll still be here.
I don't see like you know, flying cats or anything yet. So, although we did see one walk by. Okay, so Cesar Brollo is up next. Cesar is from Buenos Aires, Argentina. If you watch the Global Star Party at all, you've seen Cesar on his rooftop in good skies and bad, but he is always someone that is trying to kind of break the boundaries of what amateur astronomy can be, especially for someone on a budget. Okay, so Cesar, thanks for coming on to the program today.
Scott, it's a pleasure. Like every Tuesday, every global sub party is great to be a part of this so wonderful event, and really I enjoy to show something to share my experience like amateur astronomer, because my work is sailing telescope from 30 years. Maybe my place in the universe is maybe it's more my function in the universe is sell to the people, and but more than sell, sometimes I feel more near to talk to the people, to encourage to the people to make different things. Just I finished teaching and explaining to the customer how to use and make the first steps in astrophotography using a equatorial mount. Every time that that with many people that they told me, okay, who is the first step? Well, for example, with this customer, this guy, we started to take pictures inside the room with the turning off the lights to experiment the sensibility of the camera. This is first steps of astrophotography, that is not astrophotography yet, but is the first sensation that the technology can do it. It's something that have a magic in the first steps that are sometimes are forget when the people is going to make more pictures, and are thinking more in technology and the capacity of having a surprise about the things, about the universe, sometimes is lost. And this is why I enjoy the first steps of many people that is starting and trying and making their first steps, trying to make a picture of the sky, a picture of the moon, something more easy that they're all their own first pictures of Milky Way. But I really enjoy this. And for tonight, I have one object that we can try to make. I try to make in the next in the next weeks. It's a galaxy. It's the Peacock Galaxy, and only I show this object because I choose this because in this time of the year is a really southern hemisphere object that maybe Maxi have a great pictures of this. And I show you in the map. Let me share the screen. If I have, let me try if I have. I don't know if you can see the Carduciel map, sky map, or only you can see the sky map now?
Not yet,
only the
but
Yeah,
give
not
it a
yet.
moment.
Not yet.
No yet. You are sharing. Let me.
It says you are screen sharing, so I think.
No, yes. Yes, I try again. Sorry.
Okay.
Well, I try not. Okay. sorry, that I don't know why it's unable to share the option of carte du ciel, but let me open maybe a few pictures. Okay. Let me. I'll try to share some pictures of these objects. Okay. Well, the typical object of South Hemisphere. This is a picture that I took from my balcony here in Buenos Aires, in Palermo. But the idea is going to I don't know if I can. Okay. No, the funny. Okay. I don't know
the
how.
jewel box.
No, yes, the jewel box that you. This is the last picture that we talk about. And the next picture that I'm interested in show, it's jewel box was the last in the last weeks that I show you. Omega Centauri cluster, 47 Tucana cluster. This was the object that I took the picture from the lab few weeks ago, not few ago, few months ago, that I was talking pictures and talking about this. Next object is this from the city. I don't know if it's possible, but the idea is taken from the next weeks, and it's very important for this time of the year because it's highest over the horizon at this time. The Peacock galaxy is a 9.3 maybe, or 9.5, I don't remember exactly the magnitude number. And this is the next object to take a picture, but not from the balcony. If not, I'll go to the rooftop of the well. And why? Because it's a very interesting target from the city, because it's very difficult to have this, because in a sky that the Bortle number is 9.3, it's near to impossible, but not impossible. It's a very interesting target to choose from the city. It's very interesting because it's a huge galaxy, and it's big as like Milky Way. Many people say that it's the older doctor of the Milky Way. And here maybe you can see an accessory galaxy of this galaxy. It's like this galaxy is like the large Magellanic Cloud of our Milky Way. It's something like it's very interesting because it's a galaxy that you can see today, that we are talking about our place in the universe. It's sometimes very difficult how people I don't know how they can see watch us from another galaxy when the most similar this is at 25 million years, light years, and it's really similar. The view that we can have in the Peacock galaxy is similar. How they I don't know, maybe God, I don't know. They can watch us from another galaxy, and it's very interesting. Well, it's my target for next week, not maybe 2 or 3 weeks ahead, but it's very interesting to to have sometimes our place is the idea of the physics position in the universe, or in our galaxy, or it's something that is well, for me it's near to impossible to explain, because I am only an amateur astronomer. All time I am amazed about the idea to understand our place. It's something like I can't imagine the idea, but it's great. It's a great example, this galaxy, Pekka galaxy, of because it's similar to the Milky Way galaxy, with an accessory galaxy like a large Magellanic Cloud. This is all.
It does give you great perspective to see an image like that, and that was a great example. Just like looking at minerals that you might hold in your hand, and making the instant connection that these minerals were created inside of supernova, and then it's not, when you think along those kinds of terms, I mean, you kind of get these flashes of like realization, as you're, living your normal daily life,
Absolutely, it's mind blowing. Mind
blowing.
Mind blowing. Something that I talked with Victor Busso, the man that discovered the last supernova. I don't remember the name. Sorry, the number of the galaxy. He's Argentinian, and he's a like a lookkeeper. He made keys.
Okay.
Look,
locksmith. He's a locksmith.
Yes, but he's a genius of the observation, and he used his Newtonian 16 inches telescope, trying in his first night, trying and calibrating his ZWO camera. He discovered that something was wrong in a galaxy, a supernova. Many months later, when I was lucky to talk with him, because I know to Victor from many years. Victor told me about things like they discovered in this supernova, like a gold was made in this supernova. For example, in many supernovas, a lot of like you told, is real. It's incredible that many materials not born, but are formed in supernova.
Yeah, well, born's created anyway. Yes,
it's correct. Yes, it's bad to say.
Born's a good word too. Yeah, right.
Yeah. Yes. It's something that it's completely out of my mind, of course. Yeah.
I find, Cesar, you've done a lot of outreach with the public, and I find that when you start to talk about the distances of things, it is for people who are just new to it, maybe seeing through a telescope for the first time, or starting to even think about astronomy really seriously for the first time. They find it very difficult to wrap their heads around the distances, and you show them the Andromeda galaxy, and you tell them, this is 2.2 million light years away. We're traveling at 588 or 5.88 trillion miles.
Yes, or this galaxy peak of 25 millions away.
Yeah.
This is million.
The numbers just like that get way too big for them, and
absolutely.
It's hard. But as we become more familiar and we work with it, even as amateur astronomers, it becomes you become okay with it, and then you start to really, I think, more appreciate
Absolutely.
what you're seeing
Yes.
through the eyepiece, even though maybe you've seen it hundreds of times through the telescope. You know, it's never the same.
It's
never the same.
incredible. In this picture of Peacock that I took with Agustin, with my son, and it was funny because was the picture that I showed you, just I showed you, is a picture that we took with Agustin in a show before, after the show, to project live image to the people. And when we turn off the projector in the wall for the people that starting to use to adapt to the darkness. Eric Gonzalez, the astronomer that he visited us some weeks ago, he asked me, can you targeting to the same time of the year in winter but in Mendoza, he told me, can you target to the Peacock Galaxy, because in this time is high over the horizon. Yes, why not? But my mount is the same mount like in this time that actually use Cameron Gillis is an alta-azimuth mount, and I told him that, come on, it's impossible to take a picture of a galaxy with an alta-azimuth mount, and it's magnitude 9. Actually, in this picture of this galaxy, you can see, like many pictures of Cameron Gillis, you can see a lot of galaxies far away from. Let me share. Sorry, very fast to share. Sorry, let me try. If
Thanks, Cesar. Yeah, it's really fun. I'll be showing them again later. Yeah.
Yes, let me.
There's one more down to the star at the left. Yeah.
There it is.
Yes.
Now that one's further away.
Yes. For example, yeah. This is crazy. Yeah, and I start to take pictures while we was talking, and drinking whiskey. That is something that sometimes we drink in some star party, not all time. And another day we had the picture for stacking. We was amazing with this magic. It's incredible. Really, it's something that, yeah, absolutely.
Yep. We have some comments here. One of them
about the whiskey. No.
Harold Locke is saying stargazing is a drug. I'm sorry, but for me, it's highly addicting. Well, yeah, I think you could say that for almost everybody here, so everyone understands.
Hello, Harold. He's commented on some photos. We're now Facebook friends, so I'm waving hello to Harold.
Oh, great!
Hear from him. Yep,
that's right. Yeah,
hey, Scott,
Harold. Yes,
real quick. I got to ask you this: when are those tents back in stock?
Even the cat.
Sorry, even the cat wants to know.
The cat wants to know when the tents are back in stock. He's like, yeah.
It was like perfect timing.
2-room pop-up observatory tents.
Your cat is a genius, Simon, because he knows when.
Come on.
Yeah.
Either that or he's ready to be fed.
For what I understand, it should be pretty soon. So, it takes a cycle on making them and getting them shipped over here. That's the problem, Simon, is getting them shipped, because all the containers have been backed up for such a long time. It's getting slowly better, but, and I know that the whole telescope industry right now, all the retailers are really, it's tough on them right now because they can't get product. because last year all the manufacturers pretty much sold out of telescopes.
Never we saw this, Scott. I work in telescope industry from 30 years and never expect something like this year. Every day I explain to the customers that no, I don't have. No, maybe in September,
they don't believe
maybe in
you.
October. No, come on.
I'm saying it on this show. There's no telescopes in stock anywhere.
Yeah, yes. Don't ask anymore. wait.
You can ask.
But,
it's okay.
Sure.
No, it's actually it's very slowly coming back in, but we're all feeding back orders right now.
Sure.
So.
Something. Yes, it's
You know,
something fun.
I was going to say
sorry, Simon.
it's actually a good thing because I don't know. Dare I say this? It's not like we've sold any more or less in general, but it's the popularity since everybody's been stuck at home. Has astronomy suddenly just jumped up such a big tier?
Oh, that's right.
It's a thing that somebody wants, and it's great because I think 2 years ago, between you, me, Scott, everybody sitting here in this this chat, it was a struggle to get somebody behind a telescope. And now,
sometimes, in some ways, you know.
Yeah, and now it's just like there's no way to get anybody behind a telescope now because we can't go out. Well, we can now, I think, for at least some of us.
Right.
Yeah.
But it's so great to see so many people just get out there finally and start seeing it.
Astronomy clubs have grown in membership. I know the league has grown. I know that the magazines, Sky and Telescope and Astronomy Magazine, their subscriptions have grown. You know, we see the interest there. It's great. It's wonderful, and you know, so you know, give us a little more time because all telescopes are made by hand. You know, it doesn't. These things aren't spit out.
Yeah, I was going to say, everybody thinks they come off of some kind of crazy assembly line.
No. Even
even
the toy telescopes are made by hand. You know, it's
that's the mark of a good.
And that's, of course, you get to a bigger telescope, the optics get more complicated. Everything becomes more precision, and then of course your client is expecting you know, a very high level of precision by the time they get to a more serious telescope. So it's
so Scott, will you be at the Okie Tech Star party or someone from Explore Scientific?
You know, we are definitely thinking about being there. I don't know if I will be there personally, but yeah, we're thinking of that. Actually, we're doing a kind of a test star party that is a music festival. It is on September 10th and 11th in Eureka Springs, and so there's a whole lineup of you know, folk singers and you know, kind of new age, I guess I would say, new age bluegrass and stuff like that. Really cool stuff. And they are going to be in a place called at a concert venue called The Farm, which is in Eureka Springs, which is about 45 minutes from here. And we're supplying the telescopes for this venue. So it's astronomy and music, you know, so it's going to be kind of cool. But 2 days, September 10th and 11th, and you can look at, I'll put the link in here so that you can find it. But let's turn our attention to Maxi. Maxi is also in Argentina. He's been on a lot of our shows so far. And when Maxi first came to show us his amazing astrophotography, you know, it sunk in that he was doing this all with a smartphone, okay? Which was really, really inspiring to see what he's done with that. But he uses, of course, more advanced cameras than a smartphone as well. Maxi is one dedicated astrophotographer. And so I'm going to turn it over to you, Maxi.
Well, thank you, Scott. Hi, everyone. Hi, Cesar, Adrian, and all the audience.
You look more alive and awake than the last time.
Yeah, the last weekend.
Staying up 24 hours can do that to you.
Yes. Yes, no more 3 hours sleeping because it's terrible.
No.
His excuse is that the planets were up. So, yeah.
It's planetary season, but of course, it has to be too late. Maybe this Thursday or Friday, I will try again to Jupiter and Saturn to take it over, but I don't know yet. So basically, like the thematic of this night is what surrounds us, what is our universe. So I want to show to everyone. I think the audience is more in this northern hemisphere, so I can give some details from our perspective and our skies in the southern hemisphere. And last weekend I tried to to show you in Stellarium, but I couldn't make it. But I think this time it could be work because I found the to see in the program Windows. So
Not like me with the card du ciel that I couldn't share.
Yes, I in this time I don't have the card du ciel to try, but I
No,
will
yes.
try in Stellarium. So
Yes.
okay, okay. Do you see the screen?
Yes.
Okay.
Yes. As always, we see the very impressive total
Yeah.
solar eclipse. that
Every
just-
week
it just
you
beats everything you show us. This
Yes.
image. We're like, okay,
You see my
excellent. We can
screen,
look at
I'm
it
blowing you
again.
away with
Come
this
on,
eclipse
come
shot.
Yeah.
Okay.
Yeah.
Do you see the Stellarium?
Yes.
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 Okay. Do you see it's moving?
Yes.
Yes, it's
Oh,
perfectly.
yes.
Yep,
Yeah.
we
It's
have
working,
it. Yep,
it's
you have it
working.
working.
It's not like my card du ciel.
I think full
I don't know
screen
why
mode.
I never can share. Yeah.
I think anything in full screen mode doesn't work, but if you window it like this,
Yes.
then it works. So it
Yes.
has to be have a window in
Mhm.
window mode.
Yes. And in card du ciel share only the most ahead window of card du ciel, but the problem is don't show the map. And here work
Right.
perfectly, Maxi.
Mhm.
Yep.
Well, here in of course in Stellarium you can configure the sky, the constellations, or maybe put it like this: what you see without the names. But to you to get from some kind of what we see or what we try to see, this is out of the sky, but you can see the time is 15th of January, because was our summer skies in the night. We have the Southern Cross pointing to the southern hemisphere here, because in this place is the Polaris Australis. Okay, here's our polar star. Okay, but when we have to align our mount, we can we have to point to these 4 stars, because when we point it, points directly to the south celestial pole.
Hmm.
Okay, so this is a little tour, of course. In the north, well, it's very different. Remember, this is in January. You can see Orion here, taking down to the west. But what I want to show you is some kind of a little tour of our perspective from the south. This image, let me stop or close here. This is a picture that I took in that time of the same place. Okay, you can see the Southern Cross, the Carina Nebula, the Southern Pleiades, Alpha Centauri star and Hadar star, and also Omega Centauri global cluster, Centaurus A galaxy, and I figured out I also can capture M83 because it's right here. Let me. That thing is M83. It's not a star.
Nice.
So
That's awesome.
you
That
can
is
see
awesome.
the
It's a very rich
region.
Yeah, very
area.
deep.
Absolutely, yes.
Of course, I don't see like a galaxy because in this case I have the the 18
Magellanic
millimeter
okay.
of the on the camera, but well, this is another place in the south that you can see with your own eyes. You don't need to use a camera to see this because this is the great Magellanic cloud of la Gran Nube de Magallanes that has the Tarantula Nebula, okay, and is in this region, in this place. When you see in the sky, wait, let me take.
Yes.
When you see the sky at night, you see this kind of cloud contrasting with the darkness of the sky. But also we have the little Magellanic cloud. So it's in the city is very difficult to see it, but in the farm,
Possible. Yeah.
yes, in the farm you can see it. And also there is another global cluster. Well, it's marked me the stars, but here's 47 Tucana, and like Omega Centauri, you can see it with your own eyes. You don't need a telescope to, obviously, if you want to see it, but to give a perspective of what is that, you see it like a little not shiny star, but when you have binoculars, you realize that it's not a star. There are too many of stars. So, for example, this is 47 Tucana. Okay, this is a global cluster. This is I took last year, and also there's another little cluster here. It's a very interesting region. And also Omega Centauri, like I showed you the last weekend. This is
wow,
an extraordinary cluster, you know.
Yeah,
Yeah.
it's beautiful.
Fantastic.
And it's very interesting when you see at the,
through a telescope.
Yes,
Yes.
by telescope, it's impressive cluster. Sometimes, Maxi, when you need to impress to make something impressive to the people that you, if you don't have planets or the moon in the sky, which object you for watching only, for observing, not for astrophotography, of course.
Mm-hmm.
Who is the deep sky object that you choose to impressive to people that are not astronomers?
Well, obviously it depends of the time of the year, but
now, for example, it's a little difficult now.
It's very difficult because, it's in the city. The Omega Centauri is very difficult.
No,
because
in your area in
Chivilcoy.
Yes.
No, but
here I prefer invite to a beer to the people, not to watch by the telescope, because
no, yes,
the sky here is impossible.
No, but Omega Centauri depends at the altitude and the position of where you are, because the light pollution kills it. But if it pointed to the southwest and from my house, you can see it very good. And also,
but in summer, maybe Omega Centauri
is the most impressive
Yes,
thing.
like
no?
obviously Carina Nebula, because
Yeah.
this place is amazing to see all the clouds contrasting the shiny stars. You know,
Yes.
this is a picture of mine, but this is, you know, this year I didn't take a picture of this place.
Wow, it's an amazing photo.
Yeah.
You know, I got to ask, what is your
Yes.
perspective of the northern sky? Because for me, I mean, for most of us that are in, you know, the US, we don't see anything in the southern sky, so to speak. But for us, we look at this and see that particular nebula and go, you know, we'd love to go out there and shoot that. But what's your guys' perspective in the southern hemisphere looking at our sky going, ooh, which you know,
Well,
doesn't really happen?
I try to, you know, I try to figure it out when because obviously I want to go sometime to the north and see what you see. I know you have a lot of galaxies, and also that you have season galaxies, but there are some kinds of nebulas that I want to try to take pictures. Obviously, like Crescent Nebula. Well, I don't know if the Northern Northern Nebula. No, I don't know. I don't remember the name. Sorry.
North American Nebula.
No, Northern American Nebula.
But I thought
NGC
you might be
7000.
able to see that though, because our summer triangle, I believe you get to see that as
Yes,
well.
but it's very, you know, I can see also Andromeda from here.
Yeah.
And also I take
Stealing
pictures
all of our attractions.
you got all the
You've
good
got
ones,
Orion upside down.
Yes. No.
So you
Maybe
got
not
the
every
Orion
one.
Nebula.
Maybe in the Whirlpool Galaxy.
this.
Maybe
Well,
not.
let's
Yeah,
go
you don't
to
have M51.
this is our night right now. Okay, so to the south we have open. Well, you know, the sky goes like this. You know, to the east, to the west. So
And the moon is
this is the Milky Way, and you can see it's above of our heads. You know, maybe 1 hour earlier at 20 p.m. is above of our heads, you know. And when comes out, we
You see,
see
you
it.
guys get Rho Ophiuchus right above your heads. That's the
Yes.
thing.
Yes.
We don't.
Yeah. And then you get
This is how we see it when comes out.
the
You
Scorpion
see-
never gets that high.
No.
Yes.
Reverse. You can see how it looks.
Milky Way.
That's the Milky Way. That's all we
Well,
get. That
this is
in
the
my
Milky Way
picture.
taken in June in Alberti.
Yeah, look
Yep.
at that.
You've got both halves.
Above of my head.
Yep.
Yeah.
Both
Yeah.
halves.
You know what, Scott? I think you should do start selling astro tours where you pay, I don't know, however much, tens of thousands of dollars, and you've
Tens of thousands of dollars.
and we
yeah.
just fly all over the world to different locations and just hang out at Cesar's house and Maxi's house and just
Okay.
take pictures all
Yes.
night long.
Don't
Well,
have
I'm
to be
already
10,000
planning a trip
so
there.
bad.
Everyone's
Each person
welcome.
goes to the
I am
private
planning a
jets and
trip.
stuff that we'll have.
Also, we
I
have
will go.
barbecues
Yeah.
Yes.
Barbecue.
and mates.
Southern
Well,
skies.
you know, it's not too much of a stretch to think that we could have a Southern Sky Star party. I've got some friends down there. One of them is Cesar. The other one's Maxi. Rodrigo's down there too. And
Yeah.
so I know they don't all live super close to each other, but I think that having
There's
a
a summer
Sky
triangle
Star
right
party
there.
somewhere would
Yes,
be-
I.
The northern-
That's
Really?
what I
Yeah,
want
there
to
it is.
show you.
Northern Cross. So yeah, the north. I see
Vega,
how tough it
Altair.
is for you to
And-
image North American Nebula because it's right on the horizon there.
Yeah.
That is tough.
Yes, I think
Oh yeah, there it is.
it's
Yep.
very, very. You know, it's very difficult. But I try to take pictures in my city of the. I don't remember what is the crescent. Here.
Yeah, the crescent. Yeah,
The
it's
Crescent
low
Nebula.
to the. yeah, low to the ground for you all.
Yes.
So
No,
that's what's
yeah.
directly overhead to the north. So it's been a target for a lot of us. The Vale, yeah, those targets are easier for us because they're directly overhead.
Mm-hmm.
Then
Yeah.
we can turn and go north. There's a lot of galaxies around the northern area where our Big Dipper and Little Dipper are. Those are our kind of the
Those are the staples, basically, the
yeah,
staple
those are the
galaxies for us.
Yep.
Do you see that, obviously, that galaxy every time of the year? Or
Every time of the year we can see where I live around the 41st, 42nd parallel. M51 never sets. It's always off of the handle of the Dipper,
Yeah.
and the Dipper rotates for me around the sky. There's the Little Dipper, and there are some planetary nebulas around the our Ursa Minor. All of the zodiac signs that were pretty much named in the northern hemisphere, so they're all hanging upside down from
yes,
our
that's why I want to show you
perspective.
Orion.
Yeah,
I thought Rigel was the head of the Orion, but
yeah,
no.
well, yeah. So according to the northern hemisphere, you know, all the documents out of the northern hemisphere, everybody's hanging upside down. Sagittarius is kicked over. It's like someone kicked the teapot over in your
Yeah.
in the southern hemisphere.
But it's a perfect perspective of our place in the universe, right? It's all relative to where you're standing.
Yeah,
exactly.
We say upside down, and it's really this is a great capturing of that perspective, because you know, you see, you know, if you're in the southern hemisphere, you're brought up there, you always, like you say, you visualize you know, Orion up, you know, in that orientation with the Orion Nebula in the upper body.
Yeah, in
so
fact, I think isn't
really
there? Don't
interesting.
you have a name for the? It's like, it basically looks kind of like a cup. Orion's what we would call the lower body.
Oh, are you
there a
talking about
name
the
for that?
chalice?
Yeah.
Yeah, I think, yeah, I've heard of that one too.
Yeah, it's called the chalice because of its orientation in the south. So
right.
it's yeah, for us it's the lower body, and the sword hangs
Yes,
from Orion.
well,
I'm sure if the
I
Babylonian
hear
ancient astronomers, you know, 5,000 years ago, if they were in the southern hemisphere, we'd have a completely different constellation set.
Yeah.
Yeah.
Well, you know, in the principal object in the southern hemisphere of the native people that live here in the past,
Yes.
the natives, they have this little story about this bird. I don't know how to say el avestruz, el ñandú.
Okay.
I
want to say
2 weeks ago we are talking about what was the African big bear, but in Africa is the avestruz, but I don't remember the name again because Scott told
let
me
me find
the name. Yeah.
I want to say
search it.
toucan.
Ñandú.
Ostrich.
But ñandú is ñandú, ostrich. But we have an
Okay,
ostrich,
we figured
yes,
it out.
but this is smaller than an ostrich.
This
emu.
This ñandú.
Oh, Nyandu. So that is
it's like a
raya. It's big, but not so big like a ostrich.
It's smaller than the African.
It looks like something we call an emu, but no.
No, they've got a specific name. They're actually called rayas.
Okay.
Yes.
It's the family of the ostrich, but it's maybe when the continent.
Okay, so it's called the raya, and there's a constellation representing it. Apparently.
Because the legend says that a hunter, a native hunter, wants to obviously hunt this bird, and he was pursuing the bird, but eventually in a moment this bird goes up to the sky and stake up in the night of the sky to get a little resume. And this is the head of the ñandú, of the bird. But let me see in the stellarium. Well, let's go. Sorry, I think I went very far of the time to see the perspective. Okay, so here's the carbon or the head, but when you see in the farm skies, the Milky Way, you see the head, the neck, and the body. You know?
Okay.
Do you see it like this? This is
the dark lanes look.
This is the body,
like a rhea.
The
bird,
the neck,
yeah,
and this is the head, and this is obviously the ñandú of that native cultures.
Yes, the name for this bird was not the
choike.
ñandú, if not the choike. Yes, choike.
The choike.
It's another language, another native people. But ñandú, maybe I think that is native too. It's indigenous.
Mm-hmm. Well,
never knew that about. So there was basically a name for almost the entire southern wing of the Milky Way. Yeah, I know that in the north we don't have such a name for it. It's just what's in those sections of the Milky Way. It's the Cygnus region, the Cassiopeia region, the bulge in the core, and we barely see the northern side of the core. It cuts off for us right about, at least in my latitude, it cuts off. The further south we go in the States, we get a little bit more of the southern part, but it ultimately cuts off well before, I think well before the body of the bird.
Mm-hmm. Well, here's in the picture. This is what you see with your own eyes, the darkness of the clouds, and this part is very circle like the body, and here comes the neck.
Okay.
Yeah.
So yeah, we I think in some places south in the US they can begin to see that, but barely. And where I am, it's not at all.
It's very difficult.
Yeah, it's generally
because where I am here in California, the what was it, Fighting Dragons of Area? It's about 5-6 degrees above the horizon for us. I mean, I need to find a place high enough to be able to shoot down into it. But
well, I did some pictures of Dragons of Air. Let me show you. It was the 12. Here, dragons. So
see, I still want to try this. I mean, it's just crazy because it's just nothing but atmosphere I'm looking through, but just to even see it would just be
this is what I took the last
shooting straight up into the this is what you could get if you didn't have to shoot the earth through the Earth's atmosphere at its worst.
Yeah.
Wow, Maxi.
Nice. Or if you take 1,000 frames over 6 months, I think you begin to get that.
The dragons
it's why we appreciate both sides. And then the real key is if we get advanced enough where we're able to jump onto a platform that's in orbit and imaging from there. You're away from Earth's atmosphere. Just imagine how quickly a lot of this data could be, a lot of the data that you could get. Of course, we see that with Hubbell.
I'm actually going to throw this out as a challenge for these guys that are doing all these different commercial space flights, regardless if it's Jeff Bezos or Elon Musk, is have, the way that I look at it, at least anyway, is they're going to turn around and say they're ruining the night sky with all these satellites whizzing around. But at the very least, stick an imaging platform up there for the general public to get access to and be able to, say, I want data from here or there or somewhere, and to get that type of stuff to come back to Earth and say, hey, I know we've kind of ruined it for some of you guys, but at least we're doing something for the rest of the community to, make it accessible.
I think that's an excellent idea.
Well, they've got enough money.
Yeah, you can, and I would say do it in a couple ways. Have a wide angle, so something akin to your astrophoto camera with a 24 millimeter lens. Have a larger, have more aperture.
Right.
Have a couple of different options for us, because then we can choose to shoot a wide area of the night sky, or we can zone in on an object that we want to image, we want to study. So that would be an excellent idea. I mean, it's essentially, Hubbell is able to get all of these beautiful pictures, but it does have a certain limitation in focal length. If we want a wide angle of what the Milky Way looks like with absolutely no atmosphere to shoot through,
we don't have an option. Right.
Yeah.
That's it, Scott.
Up there.
So that's your next plan is for $1 million, you're going to help us send
the Explorer Scientific Imaging
We'll just set up
platform.
little CubeSats with
the space imaging platform.
little ED80s are all just going to go up in space.
That's right. Good.
Good. Yep. And then we can turn it back around and we can frame Earth with it, or we can go, you can just shoot it directly out into space, and then you have a spacescape that's wide. Looks kind of like that, but without Earth, there'd be a number of new things we'd be able to try and do, and a lot we would see that we normally don't see with our terrestrial pictures.
How's Cameron Gills on here twice? How's he managed to do that?
He logs in, email to
I
a
am
different
on
computer,
my-
It is time.
Yeah,
it is time.
Yeah.
Do you like that segue?
No, it's okay.
So I would like
I
to
usually, when Cameron is showing his wonderful observations, I'm usually heading to bed because of work tomorrow. So actually,
But-
with it, we started.
Here's the Corona Australis. Do you remember last weekend? The last week I want to show you. Here's Scorpius, Antares, and the place of Corona Australis is above of obviously our heads here, and this is the part where I take pictures. This place, it was amazing because
remember you
it has
showed us.
this global cluster, these clouds of the Milky Way, or part of the Milky Way, but also this kind of reflection clouds.
That might barely be reachable from the southern part of northern hemisphere.
This is a
part of.
Yeah.
Wow, love it.
That may be a target for Okie-Tex for me. If it's not, I don't know if it's going to work, because I think where the Milky Way will be, it may be too far below the horizon to catch that.
Yeah.
But that's like a
perhaps yes, because
I think it's
if
gonna
you
be
see
too far.
Scorpius, you maybe you'll see a little bit more down to the north.
Yeah,
So-
Scorpius doesn't get very high in my latitude. It about 20 degrees, if that, and then it already begins to sink.
Oh, it's like me to Andromeda.
Yeah.
Okay, so
Right.
this is my little presentation. This is
Thank you.
our perspective of the southern hemisphere.
Very
Also, now obviously only in Argentina, obviously in Chile, South Africa, Australia, New Zealand, of course.
Zealand,
Antarctica.
Yeah, New Zealand is. Once New Zealand can open back up, which I don't know how many years, always a beautiful place, lots of beautiful scenery to go along with southern skies. I think a lot of a lot of night imagers get themselves out there. I won't worry about New Zealand until later. I've already targeted Argentina as my
Yes.
southern sky destination.
Yes, and it's something that is incredible in Argentina, that you have, and this is really, you have a rainforest part that is where we have the Iguazu Falls. You have a very dry part that is in the northeast, that is Jujuy, Catamarca, or all the northeast. You have the big mountains with snow all time in the Cordillera de los Andes in Mendoza. Actually, the part that we use for the third party is in the west, is near to the Cordillera de los Andes, but it's not actually in the Cordillera, in the big mountains. If not, is in a canyon, a small canyon, nothing comparing with the Great Canyon, but it's
still a canyon.
But it's a small canyon, but it's one of, in this area, they had two different canyons. It's incredible. Only in this area that is small, then it's not small, it's San Rafael. I think that Argentina have near to, sorry that I don't remember, the 5,000 kilometers long, and 1,200, a little more maybe, wide. Sorry that I told in kilometers, because I don't remember in miles how many hours. But only to go to our third party, normally I drive, I need the complete day, because, you know, it's like a go from Key Largo to North Carolina, maybe, to compare the idea.
Oh, it's pretty far.
It's very far. Only the wide. If you go to Ushuaia, is maybe you need 4 days, because it's 3,000 kilometers.
That's a lot of, yeah.
I
think we should
have the same long, have the same, the long distance is the same that the wide in the United States, similar.
Okay.
And Chile, well, Chile is very long too. It's longest than Argentina, but not. The distance in South America, when you say, okay, we can go to a third party, plane or driving, or airplane or a fly or driving. And we start to think something that sometimes is complicated, you know, is how to say, when you have when you need to get your telescopes and your equipment from the airplane in the airport, and you need to go to rent a car. Come on, I prefer take my car, and I prefer one day driving to the third party place that and
you can bring more equipment that way.
Yes. Yeah. I need to share a trip to San Rafael with Maxi. I need to go first to Chivilcoy, take to Maxi, and still going to San Rafael.
Yes.
Okay, it's okay, Maxi?
Of course.
Take the mate.
Hey, Maxi, have you been to the Northern Hemisphere much?
The most, what I've been, I didn't pass to the Northern Hemisphere. I went only to Florianopolis in Brazil for holidays, but
not far enough.
It's not
far enough north to see the big. If you can't see Ursa Major, you're not far enough.
So you're in the same boat as us. That's cool.
Yeah. My first time in United States, watching the sky, because maybe the first time that I say, okay, I'm amateur astronomers. I was in a third party in Atlanta, Georgia, and no, this was not my first time, but my first time in a third party. When I started to see the sky, I cannot find the stars, because all in opposite my
the perspective changed.
Yeah, everything was right side up.
What do you think it does to us?
Sure, you need to
totally.
Things.
It's
total
worse than the
constellation confusion is what happens.
Come on.
Yeah.
My
Exactly.
honeymoon, I went to Miami and Orlando and
You can't see the
Bahamas.
sky out there.
But I never, yeah, it was my honeymoon. Really, I don't see the sky.
You can't see the
I don't
sky
go to
out there.
But when we return with the family to an star party, especially go to Disney and return and go to the star party driving from Key West, because we rent a house in Key West, and say, we thought like Argentina, say, okay, how many miles are 600 miles is near to 1,000 kilometers. But come on, our miles. Well, again, driving the entire day, going to Key West to Atlanta, Georgia. Was wonderful because I love to drive.
It's a great drive.
Yes, for me is the best way to first of all, that America have a great roads and very safe roads. In Argentina is an adventure. It's a little crazy driving. Maybe Maxi can tell me that it's real.
Well, I did
that's
the
something I better keep in mind.
To Valcheta.
Yeah, you might want someone else to drive.
No, yes, because we have Italian blood. We have a dangerous mix of people that come into Argentina in our genetics thing. And I say, come on, yes. Yes, but if you like adventure, you
if you like adventure, you like living on the edge. That's
what I'd be looking. I also like barbecue, so that's where I'm trying to come.
You'll do the adventure for the barbecue.
I'll do the adventure for the barbecue and the Southern Cross. Those are the goals.
Yeah.
So, Cameron, I'm going to ask you this: what on earth is Camstronomy? What is Camstronomy?
Yeah, that's what's up next.
Yes, go get him. Cameron.
Oh, Cameron. Sorry.
Okay, no worries. Okay, yeah. So the quick answer is, Simon, it's basically a personal sharing of a sky survey. It's a sky survey of all the observations I've done. Over 3,000 observations visually over the past year, and then recently I've got into imaging. And what I've done is I've categorized out of those 3,000 objects down to Mag 13 in my 8-inch Cassegrain, deep sky objects down to Mag 13. I categorized ones as I call best and brightest. So out of those, there's 825 what I call best and brightest, which means that they're even with moderate light pollution, you can clearly see them. They have enough surface brightness to be able to pick out visually. And what I'm doing is I'm going through those now with the team here and bringing everyone along in the journey of kind of resweeping those 800 and so plus visual observations, resweeping them with my newly acquired imaging camera, Astro camera. It's a 294. I started off actually with a smartphone, and I still do that as well. And then that kind of got me into the thing. And then when I got my dedicated astronomy camera, I'm starting to go through and basically capture that constellation by constellation, moving from west to east. We're going through, and about every Wednesday, I cover between 8 and 15 objects, averaging around 10 objects, and we're exploring together. And I'm talking about my visual experience. What does it look like with the picture? What kind of magnitude, surface brightness, and how far that object is away. So what I wanted to in today's session is actually take that and just kind of do a little taste in the perspective of where we are in the universe. But before we do that, I just want to recognize, I feel like a kid walking into a candy store whenever I join this team. There's so many different aspects and so many different dimensions to astronomy. And, Simon, you point out a good thing. The technology is so far ahead of what a human can absorb or process. And all the more reason why it's great to have these forums to kind of cross-pollinate and share ideas and and kind of get that groundswell of a community, so that we can all kind of work together on helping each other go through this journey together and get the maximum out of everything that the universe has to offer. So it's really really cool. So it's a pleasure to be here. Yeah. So with that said,
Very well put. Very well put.
Thanks. Thanks, Scott. So does that answer your question, Simon? Okay. Okay. So with that, let me share my screen. Okay.
I think it's the first time I've heard Simon not have to have anything to say back. I think.
Wow. And by the way, Simon, I watch all your Woodland Hills shows as well. Fantastic. I love it.
Oh yeah, I have a new one up, but
all your solar stuff.
I'm not going to go into the new one that I've just got up. But yeah, carry on. Sorry.
Yeah, no, and you're pushing the envelope in technology. It's been great how you and Scott have been working together on collaborating with these streams and stuff, and using all the different platforms and all that to, you talked about Discord and all that. This is great. I mean, it's really cool. So yeah, this is just a subset, and what you're seeing here is a Sky Safari view of my my observation list. Let me move this thing out of the way. Sorry, this is kind of in the way. Okay, so if I look at my observing lists, I've created a new list called the Camstronomy Sky Survey Explored. So what that means is these are the objects to date. We're on episode 11 tomorrow that we've shared in our weekly program. It started off kind of randomly in northern Virgo. And then I started going into Eastern Virgo, Serpens, Libra, etc., Hercules, and then down it's the last one was Sagittarius. I split Sagittarius into 2 chunks, so I'm now moving up. So where we're moving now is I was choosing, do we go to Aquila and go up the Milky Way, or we go to continue with Lyra? And I decided, based on I have a backlog of images and stuff I need to organize. so I'm going to go with Lyra tomorrow, and it will be a smaller subset, but we're going to focus on Lyra. And what I wanted to show today is just a couple of different objects, different categories of objects at different distances to kind of again recognize where we are in the universe. So if I'm going to focus in. And let me turn on my my broadband. This is my my full best and brightest. It's 821 objects in best and brightest. So I go back. That shows everything. And we're going to go. We're going to look at the Hercules galaxy cluster. We're going to look at M92, and we're going to look at the Ring Nebula. Then we're going to look at Double, and then Vega. And the reason why I'm doing in that sequence is that's kind of furthest to nearest to us in terms of light years. So with that in mind, if we zoom in this area here, and then I'm going to change the magnitude limit. Right now I've set it to magnitude 13, which is pretty much my non-stellar 8-inch Schmidt-Cassegrain limit. It goes down to stellar magnitude 14, of course, but in my light polluted skies, I can eke out magnitude 13 at the maximum if it has a high enough surface brightness. But let's pump that up to beyond magnitude 13. So and you can see where the galaxy cluster is starting to form. And let's go down to let's go to 18th magnitude. So the center of the Hercules galaxy cluster is down here on the foot of Hercules. Oops, sorry, I'm just gonna back out here. And you zoom in here. And there's one particular NGC object that I know it now. This one here, 6047. I'm gonna center on 6047, center object. And the reason why I'm doing that is because I have an image here. This is the image I took. It's not a great image, but it's my first, my 4 a.m. I don't have a cooled camera, so there's lots of noise. This is a live stack. If I go back one here, this is a live 10 stacked images of 30-second increment. But I got my flats right. Let me just move this out of the way. I got my flats right, so you can see that at least it's relatively flat. but you still have this line noise and stuff. That's another thing I'm still working on. Lots to learn and apply. But for the purposes of EAA and the sky survey, you can see a lot of galaxies in this image. Not bad for a 30-second with an 8-inch on an altazimuth mount.
Not bad
And
at all.
so, you know, what I want to highlight here is the visual plate self. Now you see this bright star here. It's down here. Now what happens is, this is today, this is current time, if I go now. But I have, when I take the images, it has a timestamp. So what I can do is, this was July 12th. So let's go to July 12th. So that, bear with me. I'm just gonna, you see how the field is rotating. So I'm gonna go to July 12th. And it was at 43, at basically midnight, it was 12:43 in the morning, 00:43. So if I figure that out, let's go choose the time, and let's go, it's PM, so it's, I'm gonna have to go like this. There we go. So now we have the right orientation for the visual plate solvent. You can see this star here is this star here, and this line of galaxies here is this line of galaxies here. Now the if you look at 6047, that's one of the brighter members of the group, magnitude 13.5. If you take a look at the information, it's 460 million light years away. Okay, so it's really darn far out there. A lot of galaxies in the Virgo cluster are around 100 million light years, 100, 110. That's what we were doing in the survey. But when you start to get into galaxy clusters, they're quite a bit further out. And then you get to quasars, they're billions of light years, of course. But these, so I just want to highlight, you know, with an 8-inch, you know, light polluted skies, 30-second stacks. Let's look at some of these members down here. Okay, so there's 3 down here. Let's look at the fainter member right down here. Click on that guy right there. It's a magnitude 15.4, right, galaxy. Actually, I want to go to even there, this one here. Magnitude 17.4, IC 1170, which is this one right here. It has a high enough surface brightness so you can still see it. But the fact that you can pick out magnitude 17 galaxies, I couldn't even do that in my 18-inch Dob visually in a dark sky. So this, well, maybe in a dark sky you could, but this is pretty darn good. And then be able to do this from your own backyard. So let's look at the specs on this guy. It's in the group, right? So 470 million light years. So all these guys are around the same distance. So that's kind of just a snapshot of the galaxy cluster. Let's move on. I'm going to zoom back out. I'm going to turn off the filter here, so it doesn't choke my machine. Let's go back to magnitude 13. I'll make it respond faster. I'm going to zoom back out. Okay, so now let's move into nearby. So we've moved from the far galaxies to globular clusters. Globular clusters are on the outskirts of our galaxy. Let's look at M92. So M92, I have a picture here, if I can find it relatively fast. Yeah, here we go. Here we go. M90, no, it's M62. Bear with me. Sorry for making everyone dizzy.
And you're actually cataloging everything as well, aren't you?
I'm building a catalog.
That's what Camstronomy does.
That's what it's all about. And ultimately, I'm going to publish this so that people can, you know, look at this. And ideally, what I'd like to do, Simon, is, you know, I know there's a lot of stuff on AstroBin and a lot of awesome stuff, but I want to, just for my own personal, but also just as part of this community, I want to kind of make a Camstronomy list that you can tie into your observing tool, and then you'd have these thumbnails, kind of like Deep Sky Survey, and be able to see what to set your expectations, what you can see and what you can image, and at a basic level. It's not going to be awesome quality, but I want to get to a certain level of standard quality where I eliminate the main noise, and I'm able to do this, and then ultimately go back and comb back and take a new set of pictures and continue the survey. So if I think Hercules is up here. Ophiuchus, Serpens, Libra, Booties, Serpens. Here's Hercules. Here's my M90. Okay, so this was an earlier picture of M92 with my smartphone, and you can see I had it all. You can see how the stars line up for the visual plate solve. This was with just a 62-degree Explorer Scientific ocular, and basically you can see pretty good. You can have some granularity to stars, but the main thing I wanted to highlight, besides is, if I go back here, this guy is in the tens of thousands. You'll see globular clusters tend to be in the tens of thousands of light years away from our solar system. So 27,000 light years for M92. And then if you keep clicking on other, taking a look at other globular clusters, they're going to range between 10 and 40,000 light years away. And then if we continue, let's move on to, let's go change back to today. And let's move on to Lyra. Oops. Okay, let's move a little closer now. And let's look at the Ring Nebula. The Ring Nebula, we'll look at the specs on that guy. It's around 1.4 thousand light years, so we're moved in quite a bit closer. We're zoomed in right a bit. So we're in our we're in our galaxy within the Milky Way, 1.4 thousand light years. So very bright. But what's neat about this, what I like about the Ring Nebula, if you zoom in and you turn on the fainter galaxy filter, galaxy filter. There's a couple of galaxies in the same field of view. I'm just going to go back. I'm going to cancel that, but take a look at those. And if I go to my pictures in my survey, sorry, this is kind of in the way. And this is in the way now. Let's move this over here. Okay, put it back into slide sorter mode. Okay, here we go. So first of all, the images of the couple of images here. This is my early smartphone images with the S8. You can see I zoomed in and very fuzzy, but hey, you can still see the central star pretty darn good, with just a simple smartphone, tacked on. So this is what I'm also trying to demonstrate, Simon and everyone, is that hey, it's a journey. We want to make it so that you're drinking from a fire hose, but you want to be able to, take sips and tap off of it and gradually get more and more advanced at your own pace, right? Because that's where the enjoyment is to be able to access it at your level and then, improve. And because it's really a self journey and self-discovery. So to be able to start off with a smartphone, which most people have, and be able to do decent pictures, it's very satisfying. And then of course it's like, oh, well, let's get a dedicated astronomy camera. And then you start to look at noise and cool cameras and you filters, and there's lots of things, but they all come in their own pace. And so this is on the left where I started to do some stacking and stretching and trimming, and pretty darn good. You can even see some double star here. You can see another star inside the you see the central star, and then another superimposed or behind the nebula, and you can see the structure. And I put the Hubbell image here for reference, just to show, obviously the Hubbell is like infinitely better. And this is kind of to your point, Simon. It's really neat to be able to see what kind of structure you can do with just your simple, cheap equipment in your own backyard to kind of identify the same type of structures. For example, this little nook here that's in the inner ring is right here. You can see that clearly. You see these, I guess, these striations or these stripes, kind of like this one here and this one here. You can start to see that. You start to see some indications of the overlapping nebulosity. This little protrusion over here, you can start to see hints of it over here. Clearly the shape itself, right, having this extension continuing here, that's the same thing. So to be able to see that is really, really cool. So now
I was going to say, funny thing is you can still see it in the cell phone picture, that little nut sticking out, the little ear on the right-hand side.
Exactly. That's right. Thanks, Simon. Yeah, you're right on. And you can see how it's fainter on these ends, and it's clearly brighter here. And you can see that visually as well, not as pronounced, but with what you can do with a smartphone is it captures your averted vision and your sensitivity of it takes advantage of the resolution of your, I got to get this straight again, your rods and then the cones. I think the rods are for averted vision, right? Or is it the other way around? And then the cones, of course, you have the sensitivity. So you have the best of both worlds with a smartphone.
Real
the
quick,
resolution.
Somebody is asking on the chat, actually, which software are you using? Not the PowerPoint software, the thing that you're using to find everything.
Yeah. So if we go, what I've done is I put Sky Safari on BlueStacks. BlueStacks is an emulator. So it's a smartphone. Normally, Sky Safari is a smartphone or tablet application, but in order to show it here, I put it in an emulator inside on my desktop. And so I'm using BlueStacks as my emulator, and Sky Safari Pro is on top of that.
Okay. I think that's where everybody got, where you caught everyone out, because even I was going, how on earth are you getting Sky Safari on a desktop?
Exactly. Yeah. So that's what you do. And it's very, very helpful to be able to do that, because what I like about Sky Safari, I mean, a lot of us are familiar with it, is I also like the live sky feature where you can, let me just quickly do this. Give me a second here. Got to get this. Okay, let's go back. What you can do with what's this thing? I lost my train of thought. What was I saying? Anyhow. Okay, so
you were pulling something up on Sky Safari.
Yeah. So yeah, that's what I was going to. Thank you. It's a live sky with Sky Safari. The advantage is I can go to my observing lists and my observations, and all of these are synchronized through live sky. So that means that whenever I do changes here on my desktop or on my phone or on my tablet, it automatically goes. I can go to the live sky website, which I think it's, I got it right here. So I'm just going to pull it up, for example. So you'll recognize, and this is really, really useful. And then you can download your object list. Okay, well, let it do its thing. It takes some time. And then what I can do is I can download the object list, and I have, where is it? I think it's in here somewhere. In my catalog. I've exported. Where did it go? Maybe it's. Here it is. Yeah. So this is work in progress, but basically what I'm doing is I'm making the catalog that you can export with Sky Safari, and let me just pull this up. And the nice part about this is it has all of my my sequence observations from Booties all the way through Virgo. How many objects I have a pivot table here, and then I have observing lists of all the objects, including my logs. So these are my visual observations as I'm recording them on my tablet. My visual observations, 3,000 or so. I actually have them all. Like, for example, oval patch, very faint oval patch, faint oval patch. All these things are my observations and the time stamp, etc. And I can do some pivot tables. I can do lots of cool stuff. And then ultimately, when this catalog is compiled, I'll be able to have visual descriptions below that too, with different scopes and stuff. So it's a massive undertaking, but I'm taking it. I think Jerry made a good analogy. It's like, how do you eat an elephant? You just gradually, right? And it's the journey that's really fun. So
yeah, I just when you said that, I was just kind of like imagining, well, where do you start? So you just like nibble on an ear or something, or I don't know. Being a vegetarian, I just have a real tough time with that one. So
So now just finishing up on the Ring Nebula, I wanted to zoom in those two galaxies that I showed you, kind of taking another look back into the distance in the same field of view. I kind of blew out the exposure here, but I'm picking up a magnitude 15.3 IC 1296. That's 256 million light years away. And then this one, PCG 2024204, magnitude 17.5, right at the end of this string of stars. You can see right there. It's clearly there. That guy is far, far away. It's not even. I haven't researched it, but I tried to Google it, and it doesn't say the distance, so it's very far away. So that's the Ring Nebula, and then last two things before I wrap up my segment on my whirlwind tour here is let's look at the double double. The double double just up here. Click on that guy. It is, see, it's 100. Now we're getting a lot closer. 162 light years. So now you're moving much more closer to the neighborhood. And if I just take a look at some of the pictures. This is a challenging object to take a picture of. You have to take. Let me just show you. So this is the actual visual plate style. This is from my smartphone. The smartphone does a better job because you can take like a video, and that's probably the best way to do it with a video, with like a planetary image, because the separation is very close, right? We're fractions of an arc second. So you're so I did a 1/8 second. To be able to do this with a single shot was quite a feat. ISO 100. So you can see that there are two stars. You can see the classic orientation, right? One perpendicular to each other.
Mm-hmm.
This is with my 294. I was trying to figure out, clearly blown out. I tried to do 1 second. It's like, okay, but just as a lesson, it's like, oh, obviously more work to be done. I probably have to take a video. I need a higher speed.
Try stopping down the telescope. Stop it way down.
Yeah. Thank you. Yes, in fact, I was thinking maybe just doing these with my Mac.
Use your Mac and go with a 2-inch aperture mask or something,
Exactly. There's some cool stuff. So what I'm learning out of this, Scott and everyone, is different equipment, different tools for different objects, right? And you start to build an arsenal of, okay, I'm going to image planetary nebula tonight, small ones. I'm going to image, I'm going to image large supernova remnant, and then you have a different type of filter and setup and all that kind of stuff. So I'm starting to build that as part of my survey, so that as I go through the full cycle, I'll become more efficient and having more satisfying results that everyone else can replicate for themselves. That's kind of the plan. So last object is Vega. Vega, everyone knows Vega. Can you see Vega? Hey, Maxi and Cesar, can you guys see Vega in the southern hemisphere where you are?
Oh, Cesar,
yes,
you're muted.
Cesar.
Yes, I can see.
You're muted.
I can see it.
You can. Okay, so that's good. So we can we look at it?
Yeah. No, Vega.
I was trying to lip read. I was going, what is he saying?
Vega is my alignment stars. Yes. Vega is my alignment star in the north. It's very easy because
nice.
in many times of the year is Vega and Lyra they're excellent.
It's nice. It's a nice beacon.
To make a go-to alignment. Yes, it's a nice brighter blue one. Yes, your picture is beautiful, camera. It's amazing.
Oh, this is not my picture.
Come on, but you have one better.
No. I didn't take a picture of it yet. But
it's not easy.
Cesar, but,
yeah. No, but I know
but this
that
this was taken with a Newtonian or something with a spider, because you can clearly see the diffraction spikes, which makes it beautiful. Actually, I love those pictures of the Pleiades with diffraction spikes. I think Richard Grace, he Astro Beard, he was he does it that way, and it's really gives nice, satisfying results. So yeah, 25 light years. I mean, this is a nearby neighbor. I mean, it's really close.
Yeah.
So
Don't throw away.
so that's where we are in the universe. So taking a zoom back, what we did is we went from the galaxy cluster in Hercules, a globular cluster, down to the Ring Nebula, and all within this small area, you have that wide range, everything from, 500 million light years away, half a billion, right? 400 and something thousand light years away, or million light years away, I should say, down to tens of thousands and into thousands, and finally tens of light years. So, so that's my my thing. So tomorrow in Camstronomy, I think, yeah, it's gonna be a little bit shorter this time, Scott. I want to just do Lyra. So and then we'll move on to. I have lots of juicy stuff. You can see my pile of images. I got lots of stuff in Cygnus and Vulpecula, Sagitta, Aquila. We're going to do those chunks in the following weeks. So that's yeah. So thanks a lot, everyone.
Hey,
any questions?
People just commenting here. Harold Locke says Vega and the whole summer triangles in the clear right here. Let's see. Harold Locke says 100 years from now, the Gillis catalog will be the standard go-to source. Might be.
That's flattering, but I know there's a lot of people that are further ahead than I am, but this is just fun to be able to share.
So Scott, for $1 trillion this time round, I think we can, $1 trillion per person. We're going to send a probe to one of the stars, right? So we've got for a few $1,000s, we can do the Southern Hemisphere Star Party. For a couple of $1 million, it was something else. I forgot what it was already. So now for $1 trillion,
once you got to $1 trillion, it didn't matter anymore.
We're going to Vega.
Yeah, sure.
Yeah,
if somebody pay 28 million for a chair in one,
I could have some fantasy star parties. I mean, the South American Star Party, I think, is a real thing that we can put together.
No, it's real.
And if I was doing fantasy star parties, what would I do? The great Omega Centauri Star Party, where we fly to some huge globular cluster.
You know what? Can you imagine that? I mean, I can just see it now. I don't know how long it's going to be. We'll call it 50,000 years that we're going to have a Scott Roberts on a screen giving us a guided tour of Orion or something like that.
Floating in a glass
That's
jar
it. Just
something.
that.
Yeah. Okay.
No, you know what's going to really happen, Simon and everyone, is there we're going to have AR, and then there's going to be probes. Probes will go out there, and we're going to be able to just
AI,
experience it.
robots,
Robots. And, we'll all have hollow rooms. One of our bedrooms will be converted into a hollow room.
Cool. Well, I'd like to reintroduce Rodrigo Zelada to everybody. Rodrigo's been busy not only with his business, North Optics, but he is embarking on becoming a research astronomer. So, which is totally cool. And I'm glad that you were able to spare some time tonight, Rodrigo, from your work. So, thanks for coming on.
Sounds good. Well, I started study astronomy in Chile, and my first job in my first study is a diploma in astronomy, and I work with an astronomer with the project BBBX in Paranal Observatory.
Wow!
And it's an I share with you my presentation is a little presentation.
Please.
For this work is amazing work.
Oh, a super survey. Awesome.
Okay, do you see my screen?
Yes.
Yes.
Okay. Well, in the university one teacher, Dante Miniti, astronomer, is Argentine, the Argentina. Tell me, do you work for the images of the BBX? I very work for you. and yes. And the project BBX is a survey in the Milky Way. First, the survey in the center of the Milky Way, and the last images from the solar disk of the Milky Way. And I work in a little area near to Alpha Centauri. In my work, I think in the universe, the galaxy is many galaxies. For example, the Hubbell Deep Sky in the little sector of the space is many galaxies. The project BBX work in near infrared in the study only the Milky Way, but in the Milky Way the dust and the gas stop the life for the star or structure behind the galaxy. This telescope is work only in infrared in three narrow band, the infrared, and I work in two images. And the infrared, my work is look for the new galaxies. The Milky Way stop the life, the another galaxy in this area in Centauro. First, the infrared is monochrome images, and I assign the false color to create the RGB images. And in this area, I check the data and don't know a galaxy in this area. In my image, I search the new galaxies, and the infrared show these images in the little area with dust, and this star don't see for the dust and the gas for the Milky Way. And in this area, it's a new galaxy. For example, this point is a new galaxy in this area. 96 new galaxies in two fields, and this is a sum the galaxies. And now an astronomer for Argentina worked with this data for spectroscopy and photometry this galaxy. And this is some galaxy in this area. And this is the complete image in the little area in the Centauro. And this is a big galaxy in behind the dust of the galaxy, of the Milky Way.
Sorry, Rodrigo, real quick, go back. Oh, you've closed it.
Gotta be quick.
Yes.
What spectrum are we seeing here on that image? Is this visible, or is that a combination of what you just showed?
It's a combination for the infrared.
Oh, okay.
Is infrared and visible, Rodrigo, or it's only infrared?
Yes, the infrared is the near infrared.
Yes, a near
Oh, okay.
infrared.
Yes.
Okay.
Yes.
Yeah. Looks like visible, but it's maybe, I don't know, is the
Yes, this area is the visible, and the
okay.
near infrared is outside the visible.
Outside the visible, yes, but very near to
Very
the,
near to the visible.
Yes.
This the near infrared, and
Yes.
for RGB composition for the infrared, KS band is red color. The H band green color, and J band
for
blue color. In high low energy to high energy, similar to the visible light.
Yeah.
And combine this band, create RGB image like a monochrome camera.
It's amazing.
That's great.
How big
the
is
size of the sensor? Sorry.
Oh, I was going to ask you the same. I was going to ask the same question.
Yes.
Who is the field?
Yes, es 1.2 or 1.25 degrees. It's a little
okay,
area.
the field. Okay.
Yes, 1.1 degrees approx.
Right.
Wait, so how big is the sensor then? I missed that.
I think that maybe the sensor is really huge for this field.
Yes, the telescope is a wide field telescope. Is in a Ricci criteria F 3.3
wow
telescope,
and the diameter is
a wide field telescope. Is a survey.
Yes, it's 5 meters, or sorry, no. How many meters is the
4.1?
4.1, and it's 1.3 f1.3. It's a beast. It's
holy smokes.
Yes, 5 meters, no more than 5 meters of focal
length. Is that 1.3?
Yes.
F3.3 and
diameter is
or 3, 1 or 3.3 or 1.3, because it's very
3.3.
3.3. Okay.
3.3.
Wow, you could roast you know.
Oh, come on. And the size, I can imagine I can't imagine the size of the sensor, because it's huge. Because if you have, yes,
it's a big sensor.
So this is from Conal Observatory.
It's like
I can share my
like one of the
Yes, this telescope is a Conal Observatory. Is a little telescope like the VLT, but
this is the aerial view from their website.
Yes,
come on. Yes, survey is.
That's a very impressive.
I remember that, but it's impressive.
It's a little village.
I brought in our chat that they say that the plane is starting in the San Rafael, start Paris, and cross to the Andes, go to visit the observatory with Rodrigo.
This telescope is called Vista telescope. It's the little one.
Oh, this looks like it's really high up.
It is.
It's in Cordillera de los Andes.
Yes. You can break here. You need
when you go to CTIO, they have these same kind of grates in the ground, and this is where all the wires run through. And they have them underground like that because I think it's a fox or something comes out and eats the wires. So when I was there setting up for the eclipse in 2019 at CTIO, we were laying all this, the fiber cable and everything down underground underneath these grates, and I said, well, why are you guys doing that? And they said, so the animals don't eat them.
Meanwhile,
yes.
Yeah, meanwhile, we get eaten by the mosquitoes.
Be careful, Simon, with your cat. Maybe
there's no mosquitoes up there. It is high.
It does look, I was going to say that it looks like there's nothing up there.
Yeah, it's beautiful. I can only imagine what the sky looks like from this observatory complex. Probably, well, you could tell us, Rodrigo. Is Paranal similar to CTIO in the sky?
The sky is better. The astronomer like this better sky for the CTO.
Paranal's better. Okay, wow.
Yes, it's more north the Chile, and it's more dry.
Yes, it's more dry. This is something that I think that is incredible.
I tell you, my views of the Milky Way
desert.
CTIO were mind blowing. So I cannot imagine it being better.
I
will have to visit sometime. That will be great.
So that's it, Scott. So for a low price of $3 million per person, you are going to build an observatory up there for everybody to use.
That's right, for only $3 million.
Per person.
Oh, per person, okay. Yeah, well, knowing me, I would just get it and then just let people use it for free. So anyhow, look, guys, why don't we take like a 10-minute break? If you still want to cover some things, we can, but let's take a 10-minute break and then we'll come back and do the after party. Pekka said he might show up, so we'll see. But Rodrigo, thank you very much. It was very, very impressive. And,
Rodrigo,
we
are happy to have a
future research and
astronomer.
Yeah, it's awesome.
That's awesome. And I work for astronomers in Argentina.
Yes.
We're getting killed by the people in the southern sky. I'm telling you that right now.
I know.
Yes. I think that people, astronomers from Chile and Argentina work together and they're genius. I don't know how many Argentinians and people from Chile is working in Paranal, but I think that I know that many works in many projects. The astronomy in Chile from 20 or 30 years to now, it was growing a lot, and they have a huge how do you say, a huge projects, really. They're amazing. Nice. And now Rodrigo is in the team. We are proud, Rodrigo.
Yeah. Nice. That's right. Rodrigo, you're not going to forget us when you get really famous, right?
Yeah. No. We have the plan for next year, or I don't know when, but we're gonna start in Argentina, going to the barbecue for a small star party in Chivilcoy, go to the Andes, Mendoza, San Rafael star party, cross the Andes, and go with Rodrigo to visit the observatories. It's okay.
It's okay.
Okay, so we need to tack on another $10,000 to the price list then.
No, but remember, like I wrote, if you actually in Argentina, we have a huge crisis that not is in Chile. In Argentina, we have the problems. In Chile, every year is okay, but in Argentina, our economy is never is so high, but it's okay, bad, okay, but it's every year. Simon, it's so difficult to explain our life in Argentina, but I don't know. Why
it's the government of Argentina is trying to.
Maybe Rodrigo that is, but Maxi and me, yes, it's an adventure, but come on. And actually, if you show some dollars, and say, okay, come on, you have everything from. But because it's our economy is a roller coaster. Is the best explanation. But okay.
Well, unfortunately for us here in the Northern Hemisphere, here in the US and probably parts of Europe, for the people that want to come along to this party, they're going to pay in US dollars and they're going to pay hard.
Of course,
No,
come to Argentina.
Go. Yes, come on.
Remember, we have meat, we have barbecues. Remember?
Oh, yeah, exactly.
Sure. Yeah. Yes. We are in trouble if we receive people vegetarians, but
we're going to convert to eat meat.
Yes, but Simon is not vegetarian.
No, I'm not vegetarian. I'll eat almost anything, literally almost anything. Bugs, you name it.
Okay.
Yeah. Who is your country, Simon? I don't remember. Where are you from?
Right now, I'm actually in the US.
Okay, because you have a English.
Yeah,
Awesome.
well, I was born in London, so I
came
here.
Have a
British
UK.
Yeah, I was born in the UK, British. So, but I live here in LA now. Well, I say here, it's wherever here is to me.
In Georgia? Where do you live in the United States now?
Los Angeles.
Oh.
Los Angeles. Okay.
Yeah.
That's what we told in Spanish. Oh, amazing. Yes, I know that it's like people in Argentina that they came from Korea. We have many. For example, this is for me. We have a huge community for example, from Korea or. But especially Korean is people that when they start to show in Argentina, normally, actually, they are the second or the third generation. Japanese people is maybe the fourth generation, and when you sometimes sometimes you are expecting that in touristic areas with a guy that have maybe came from a country from Asia, and when started to talk, "Che, ¿me podés decir that this is a very Argentinian accent?" I say, "Come on." Because many times I start to, for example, we had a store in a very touristic area, and the funny thing in many countries in South America, especially in Argentina, is that you never expect who is the face of a typical Argentinian. You start to talk in English for a minute and say, "No, soy de acá nomás." That they say, "Come on, I am from Los Angeles, like 4 blocks from here." And maybe you thought that, oh, this guy maybe came as a tourist. No, he's a neighbor from 2 blocks. It's all time is a mix. For example, Maxi had the family from France.
Well, there's too many
a
places.
Mix from France, yeah.
France, Spain, Germany, some kind of Brazilian, and also from here, native from Santiago del Estero. It's a mix.
A mix, yes.
A mix.
I got to ask you though. It's weird because I think we are spoiled here in the US in terms of like access to equipment. How is it for you guys down there? In terms of,
yes, remember that my business is selling.
No, I know what you do, but I mean, I'm so curious to understand it.
It's a great question, Simon. It's a great question because in Argentina, Chile have a better economy because when you visit Chile 1 year, another year, they have it's something that Rodrigo can say that. That have a great economy. Stable, yes. Chile is stable. Argentina is a roller coaster.
This is 200 pesos Argentine
the whale,
pesos.
the whale.
The whale.
The whale is like
And
a little fish now.
This is like $1.17. Okay.
Okay.
So, well, a telescope to buy a new telescope, like not an amateur, just like a beginner, is maybe like 15, 50
Yeah.
or more, like EQ2 with 140 millimeters of 9 millimeters without motorized and everything. So the economy is very, we have too many inflation. So our peso, our money, is in the
devaluation is
devaluation.
Yes, the public debt, the public spend is ridiculous, and it's something that Chile have a better really idea of an economy, and here is ridiculous. And this is why every year the people is poorest. They are actually for the people. I know that I sell telescopes, but sometimes I need to resolve for the people that for example, something that Scott knows is sometimes I make orders to explore scientific. This is something that is our backstage, but it's interesting to the people to know, because for example, 1 year I prefer sold only months like 100, Exos 100, and the people put their own reflex camera with their own teleobjectives to start to make photography, and choose in the second year choose the optical tube assembly. They say, come on, but this is real, because it's people that have opportunities to buy something. Me or Maxi, we are people that work. We are fortunately we have work. Of course, that exists people that we have a lot of inflation, but it's like a utopia. It's like it's
perfection.
Yes, it's something that you say, come on, it's a rich country, because if you listen about Argentina, the exportation of foods or some have something of technology, many cars are made in Argentina, but with a very bad system of economy, the things never work properly. It's something that, come on, but it's a great country. The people is funny.
Simon, when I started in this hobby, but now I'm going to try to be a little bit more professional, I only started with my cell phone. I don't know if you saw some pictures that I took.
Oh no, I saw them all.
Not the moon, the deep
not
sky
only the moon.
objects.
Yeah. Yes, the people, something that I can say, because I saw to Maxi from the first day that he's starting to post pictures for deep sky, but 3 years ago maybe, or 4, I don't remember. And the only thing that I makes some support to Maxi was, Maxi, only change to another eyepiece if you are using your cell phone. For me, was fantastic, because he was in Argentina the first that started to use not Xiaomi, the another way, Huawei cell phone, and maybe
I think I've seen these before.
Yes, but this one, I think that the old ones have maybe 3 years,
3 years.
Yes. Yes, I remember the answer. Okay, Maxi, try with. I don't remember Maxi. That if I tell you that change to only the focal length of their eyepiece, he told me okay. And he make a much better pictures only because he understood and he had a great energy to try and come out. He was mind blowing. When you have in the social nets, when you have people that it's working with astrophotography with big equipment, and they told him that no, astrophotography is a serious business, only with many years to try, and he maybe
a professional gear.
And he's starting to maybe in few months to make the pictures with the Huawei, and I say, come on, Maxi.
Maybe it's not like obviously the perfect picture of with very good colors, without noise and everything, but for a beginner to start to try to know the sky or what's around it, it's a good moment to see what you have in your pocket, and you with only pictures of 30 seconds in raw formats that it took pictures today your cell phone. You can stack it, process it, and you have and you get a very good picture of a deep sky object. I like Cesar said, I remember some people that say no, the astrophotography is only with a professional camera.
I remember, yes, or only with reflex camera or CCD. But they say, come on, don't worry, Maxi.
I only,
I remember this. Yeah,
that's encouraged me to prove to them that you can do astronomy today with everything. You can draw it. You can take pictures with your cell phone. You can take pictures with a DSLR camera, with a webcam.
That's true.
Yeah.
I think people keep forgetting that astrophotography was originally done on 35mm film. I mean, I know Scott probably remembers all of that crazy stuff.
Sure. I'm not, because I am young.
Well, that was amateur.
No, Simon, yes,
that's for sure. I showed, a little bit earlier my 8x10-inch glass plated balloon shot on the 100-inch at Mount Wilson.
Oh, you actually did that then?
I didn't do it.
Oh.
It was done.
Yes, I have pictures.
I pulled it out earlier. Okay. So you can see the date on this. October 24th or 21st, 1924.
Whoa.
Glass plate's almost 100 years old.
How do we make your screen bigger? Because I can barely read that.
Oh, okay. Hold on.
Because I genuinely want to see this.
Yes, I need to see.
Let's see. Let's do that. And
in photographic.
Can you see it? Or do you want me to share my screen? Here.
Yeah. No. How do we make your screen bigger?
How about that?
There we go. There we go.
Okay.
Wow.
October 21st, 1924. This is plate 306.
And it's in there.
It's in here.
Beautiful.
Yeah, let me get it. Now,
yeah, don't get your fingers on it, otherwise it's going to degrade over time.
Yeah, it does. It's already 100, or nearly 100.
Let's hear some time.
It's so beautiful.
Whoa!
Yeah. A plate.
Wow.
The moon.
Beautiful.
Oh my.
Can you imagine? And it says on here.
I think that is the daguerreotype. I don't know in English how this.
the
Iron.
daguerreotype. Daguerreotype.
No, this is not a daguerreotype. This is a glass plate.
Glass
How
plate.
old is
Okay,
that?
glass plate. Yes, it's because yes.
Oh God,
Scott?
Scott, please don't drop it.
How old is
Beautiful,
that?
Scott. Beautiful.
How old is that?
Come
No,
on.
what was it?
Hey,
19?
Pekka.
Pekka. Hi, Pekka. How are you?
I'm
94
fine.
years old.
How much?
Or no, 96 years old. No, not
My
even.
God.
Hold on. This is 2021. 97 years old.
3
Yes,
more
near-
years.
Near to the 100
Yeah.
years.
So this
Yes,
was
plate.
this was
It's a
shot.
glass plate.
Fred. I can't read all the
Should
names
you
here.
shield it somehow in
But the guy that shot this shot a bunch of stuff of the moon, and this is through the 100-inch at Mount Wilson.
Yeah. Beautiful.
You know, the funniest thing here is though the resolution on a glass plate is actually going to far exceed any digital sensor that can take a picture of the moon. That's the killer part of it, and that's the part that I love is the technology. Right. Even old technology is exceeding today's technology.
Yes. And maybe I don't know the size of the grain, but maybe in many type of plates you don't have a real grain. If not, it's only how do you say? Only the grain is the molecular. It's I don't know if in this glass plate
that's
like this, but maybe yes, because
you can see the tarnishing of the silver actually on the back, and
yes, don't have grain. It's maybe so
they're very fine silver halide crystals. Is what they
yes, it's the size of the crystal. Yes. But it's very, very small. And it's many times, and this is something that in technology, it's the connection between optics and the pixel size. And this is something that Rodrigo, maybe that working in professional astronomy now, knows all time for the finite astronomy, is that many times the size of the airy disk is bigger than the pixel size, and this is why the connection between the technology and the old optics is something to know. What if you like that all work together, you need to put in a perfect conjunction the airy disk that is light, is physics, with the size of something that is a small pixel, and this is incredible because sometimes in 1 year's 100 years telescope today you can return to the life with a newest camera and have again the old telescope coming to the life.
So Cesar, there's one of the people watching this program, I think it's Harold Locke, wants to know how he can help support the renovation, so, whether that's through, financial contributions or, he wants to talk to you about this. So, I will, Harold, I'll get your email with Annie, and we will connect you with Cesar, and you guys can have an offline conversation about it. So
yes,
it's
that's great for us because in a few weeks more I'll return to work again in the restoration of San Miguel Observatory. Actually, we are only awaiting the position of
the measure of San Miguel over the observatory. This is something that we are working with a Gustav Huygens telescope or SIZE telescope that have more than 100 years. And we are only in trying this telescope, we are obtaining huge and beautiful pictures of the sunspots or the moon in the night with modern cameras. This is something that it's great, return to the life, this kind of telescopes. For me, well, it's a time, you know, where the big refractors or medium size or small, like the telescope that we are restoring, was made with a huge quality. It's very interesting to use them and, of course, bring to the life again.
Right. That is very important work, you know.
Yeah.
I think that a lot of these instruments still can have major influence upon their communities. You know, they can still do science.
Absolutely.
You know, there's a lot of, you know, and so for them just to be abandoned and to be, you know, damaged by you know, vandals and stuff like that, it's terrible, you know. So
yes. Every week in Argentina, we think that it's only a problem of our country, but in the world, it's something that politics are the same. I was amazed that how many instruments from for example, Mount Palomar Observatory, that is not only the big telescope, with not a lot of different telescopes in the area, or instruments that are bringing to the life again. I watching all time the Facebook friends of historical observatories, and they are making in many places people that are making a huge work to restoring historical observatories. It's really great. It's great, and we are waiting to start we started, but we need to have the position to start strongly to restoring and putting in functions more quickly as possible.
It's going to take. It will certainly take money and effort,
work,
and volunteerism. You know, for people that might
absolutely
maybe you know, maybe you can think along the idea of having where people travel down there from the United States and they work to help to restore the observatory. So, you know.
Yes, it's very important to don't miss this type of things, because it's part of our culture, our history.
Yes.
In different communities, of course. And when you listen, come on, the observatories like Hale or Yark's observatory, where you work a lot to restore. I watched the huge eyepiece that Explore Scientific donate to the observatory, and this is great because you bring to the life an old one, a biggest telescope with a new technology, and have the possibility to put the eyes in the biggest refractor in the world. This is amazing. It's something magic. It's incredible.
Thank you, Cesar. That's great. Well, Pekka, how are you?
I'm fine, thank you, Scott. How are you, yourself?
Oh, good. So we've had a good night tonight. We ended up, the last part of it was with Cameron and Rodrigo here. Rodrigo was showing us his work at Conal Observatory. So Rodrigo is becoming he's gone from being an amateur astronomer to becoming a professional research astronomer. So
that's
very
nice.
cool.
So nice. Okay, right. Cool. I have to watch the beginning as reported.
Right.
Because I have a lot of lack of that processor's time of sleep. So.
Oh yes. Right.
So
what is happening in your area with light pollution?
Light pollution is right now is because it's summer vacation times, so everything almost closed until mid-August. So this is when everybody is almost on vacation. So Sweden stands still right now. We have COVID. We have summer vacation times. We had a
nothing's happening.
Government crisis. We still have a
government crisis.
Yeah.
No.
And and they have making a new budget for next year. So my light pollution fighting it's like white flags from everywhere. Please.
I see.
We must have.
Pekka, I listened to you the other day when you say me in my Facebook page for my birthday. I grabbed something. Maybe in 50 days it comes here to my home.
Yeah.
I don't know how we're going to pay it, but
it will. It will.
It will be maybe a change a little bit.
Yeah.
It's a new astrophotography camera.
Ah, nice. Nice.
So
which one, Maxi?
HD. No, I buy a CWO 533.
Oh, 500.
Una 533.
533, okay. Yeah.
It's a square sensor that has 3.74 microns of pixels, and it's going to down. I think it was 80 quantum efficiency, and I don't remember another classified, but
that's really good all round camera, because you have pixel size like DSLR are, and you have a nice moon camera there, and also deep sky.
Yes, because I want to try to get more professional.
Sorry. Real quick, let's say goodbye to Rodrigo because he just messaged us.
Goodbye, Rodrigo.
Bye-bye.
Buenas noches. Descanses.
Oh, I see.
Rodrigo.
Rodrigo. Good night.
So we lost. No, who did we lost?
So I want to take pictures with a better resolution of galaxies, and with my F4 telescope gives me some kind of FOV, but I think it will give me some big details of different galaxies, and also with some kind of nebulas. Maybe it doesn't fit a lot, but it will change something. So I hope that came. I have to see with the aduana. I don't know how I'm going to pay the importation, the taxes, but I buy it. So I think in 50 days, the pace that say it's going to be here. Unfortunately, that camera is only color camera.
Yes,
it's not monochromatic.
Yes, remember that we are going to be Saraco, our company, with the representative to the dealer for CWO in Argentina.
Oh yes,
but of course. Because the QHE,
like Gastón Posse, y ahora me lo venía a decir.
No, but no, but actually it's the same because no, I'm happy. Why? Because you are an excellent ambassador for the brand that you choose. Actually, we need that. You choose Explore Scientific Telescope. The SWVO for me is okay, but of course that.
Okay.
Yes, we need. Yes, I need to sponsor a little more.
He says it depends on how long it is. He says he expects to take some time.
I think Cameron is
okay,
yes.
yes.
Microphone.
It's a good microphone for yes. But it's no, it's great for me. It's really great that you choose set as the review. Unfortunately, I don't have that. I love the another brand, that have HQI. It's
QHY.
QHY.
Yeah.
Yes, QHY. But the competition have this brand, and we choose ZWO. That okay. No problem, because I can give you support. No problem.
Okay.
Yes, it's okay, Maxi. It's okay. If you can don't pay the taxes, it's much better.
Yes, of course.
If you buy in Soraco, you pay the all price, final price with taxes, and okay, it's legal, but it's legal, not illegal.
Cross our fingers and help me.
Yeah.
So, well, unfortunately, I think I sell my another telescope, the
You're gonna
F5.
sell a telescope? That's illegal to sell a telescope.
No,
Yeah.
that's why my
Which one?
fiance says
The Celestron?
No. That's I still have it, but the AQ5 and the 150 millimeters, the F5.
The ES5, that is the yes, and actually we are which telescope you are thinking? In which telescope?
Right now I'm still having I'm going to still have the
same OTA.
Yes, exactly, but in my living room, that is where I eat too. I have in a corner the 8 inches, and in the another corner is the AQ5 and the well. Let me stop the.
Yes, show us your telescope, like
What? This is going to go away.
Yeah, 6 inches.
This is going to go away.
And this is well, it's going to be.
Yeah.
So
you're well equipped. You are well equipped.
Well, my fiance says someone has to go. So
someone's got to deal.
Me or
and you're hoping it's not you, Maxi. Yeah.
Maxi.
Maxi, think twice. Think twice. Because you're gonna regret. You're gonna regret. I did so my.
She doesn't know about the camera.
Okay.
I think I'm going to paint it black.
You know, this is a live streaming program. She's probably
no, but she's not going to see it.
And she's on her phone going, "What?"
No,
I have. No. I have.
In Finland and Sweden, we say that you are on a very thin ice. You are walking on very thin ice.
Yes.
Okay.
Yeah, it's a great, very understandable.
Yes.
But with lucky, we are in winter, so the ice is maybe a little
thicker.
Thicker,
yes.
Yeah.
But it's cracking.
I think that
yes, correctly.
You're walking in very thin ice, like Pekka say. It's the best description. Yes. You need to leave one telescope.
Yes.
If you like white color tube, I'll receive 5 inches Apple refractor from Explore Scientific.
Oh, of course.
Only 2 because I am our friend Kent. Scott know that they say Kent. Yeah. Yes. in a time that telescopes are so weird because don't exist telescope. We are waiting the max and awaiting two special 5 inches Apple Explorer Scientific. I think that one is for me. I don't like to sell again.
You can.
Come on. No,
you can give me the another one if you want.
No problem. No problem. I'm happy if a friend is going to buy one of these. But I don't like to be hope about this because ever in this time especially, come on, I need to solve it. But I'm start to imagine and say, okay, is it one for me? I can
After
avoid
30 years of
access
selling
to
telescopes.
yes.
Now you can have what you want.
No. Anytime that because for Pekka, Maxi knows or Simon in our store we have a showroom, and for me all time I keep for our staff. I say because we need telescope to try, to study the quality, but and bring to my home a telescope that I keep for 2 years, and of course it is something that I sell telescope, but I am amateur astronomer. I love astronomy too, but in the last 2 years with this drive of telescope. With this small number of telescopes in stock, many people say, okay, I need a telescope. Who is this? No, this is not for sale because it's only for our staff to go to star parties and say, but come on, can you sell me this telescope? And when I say yes, okay. Maybe the worst part was the last year that they say, okay, no problem. I can solve you on a special product because we use this telescope. And I thought they say, okay, in 1 month more, I can receive another 5 inches Apple for telescope. No anymore. This was in September last year, and yes, the manufacturers don't have more telescopes.
It's funny. It got to a point for us where the only thing that we had left in inventory is broken stuff. And the worst part of it is customers were still trying to buy the damn thing and say, we'll fix it. It's fine. It'll buff out. I'm like, yeah, okay.
Yes. No. Yes. It's incredible.
That dent in the glass will just buff out.
No, yeah.
No, yes. You can.
If John
black paint in there, it's gonna be okay.
I think if John Dobson saw that, he'd probably strangle us.
Yes,
this
people
would be okay.
Second-hand market here in Sweden, it's blowing up now because those who bought their beginner scopes just when COVID started, and now there is a bunch of Newtonian 130 millimeters and 117, and so it's. I have a notice on my phone when somebody puts on the sale. I get the peep on my phone, and it's only Newtonians 130, 130, 130.
Yes. Only toy telescopes or really beginner telescopes.
Yes.
For medium.
We have one really
or
fine astrograph for sale. I think it's for $4,500.
Yes.
I was watching about that, but nah, I have mine. And what I saw now when I was capturing Jupiter with my Celestron 8-inch, when you get united with your scope, it delivers. But you can, I think of my scopes, when I put them on the mount, we get to get united before it delivers exactly what I want. And it will, when you are, what it can deliver, you get it. But you have to choose the right scope for that moment.
Right.
And I was between my ED 120 or my 8-inch Celestron for Jupiter. And I didn't know.
Do you have both the 8 inches
both.
and the 9? Yes, they choose the 9.25.
No, I don't have that one. I have 120 millimeters refractor.
Okay.
And 8
the 9.25. Yes, 9.25.
No, I don't have 9. I don't have 9.25. I have 11-inch CST and
11-inch. Yes. Sorry.
But the
sorry
11
I
inch,
remember that you have 11-inch.
Yes, that's too heavy for me to lifting on the mount, because for my operation, I am not allowed to lift that heavy yet, because my how do you say, the stinks and so on and everything, they had not leaked yet to lift off on that 11-inch. I have to train my stomach muscles to be ready to lift that heavy thing. But I can share my picture of Jupiter.
I watched it. Yes, it was wonderful. I like to watch again.
Sorry, I'm going to cut in real quick. I'm going to say goodbye to everybody because I know what the cat wants. She wants me to turn the AC back on because she keeps on, going to the AC.
It's hot in here.
It is actually really, really hot in here because I turned my AC off now, so it's really killing me.
I would ask you before you leave, Simon.
Yes.
About Lund and solar.
Mm-hmm.
And I have got my first light, but with the pressure tuning.
Yep.
Because when you are going close, first you have like overexposed, and when you are tuning inwards, you get those fine details.
Right.
But when I got really close, I get this dark, dark line in the middle, and like overexposed on the both sides. Do I have to have before I get those details and then just with focus and with exposure time to get those features, or should I go so close and then tune it?
Okay, are you using single stack or double stack?
Single.
You've got the pressure tuner, obviously.
Yes.
This is what I would suggest before you tune the scope. Set it up, let it acclimate in the heat with the Lunt 80. And then where it's you 50, see, or the 50, they're pretty much the same. Yeah, so where you see the pressure tuner, turn it until it comes out, and it will go pop, and it will release all the air on the inside. And then put it back in, and then start to tune it, because it sounds like what's happening here is you shouldn't have a sweet spot on that scope because it's not a tilt tuner; it's a pressure tuner.
Yeah.
So when you release that pressure out and then you put it back in, it should even itself back again.
Okay.
So if you've got that black line, or you've got one side brighter than the other, then there's something wrong with the pressure on the inside.
Just like the Edelon's tilted. So it's wrong.
It could be the O-rings.
Don't keep
also.
Moving the dielectric.
Could it be the rings? O-rings leaking?
No, it's very, very rare, because you will know when you turn the pressure tuner, it gets harder and harder and harder, and you feel it.
Yes.
So if there was an O-ring leak, you would actually just go off band within seconds as it leaks out, because as more you turn it, there's more pressure.
I will pressurize first, leave it out again, and then fine tuning in again. And then
release the pressure first.
First, totally.
Okay. And then put it all back in, then let it acclimate for about 15-20 minutes. It does not take long on a solar scope.
Okay.
but do not point it at the sun. Just have it out so it can acclimate. Then you can go. Try that first.
Okay, and flats, how about flats?
With a 50, that's going to be really tricky to do a flat frame, to be totally honest. The only thing you can really do is get something like a white t-shirt or something that can diffuse the image without change.
Fire capture had flats in the program.
Right, but you still have to make the scope be able to take the flats in the first place.
Okay.
But with a 50 millimeter, it's very, very tricky because you've got a lot of black and then you've only got the sun on the middle, for example, because you're obviously going to have full disk.
Okay, I will then just train the pressurizing tuning in the beginning. And next year, okay, a little bit more.
Because the lunts do not suffer from what we refer to as angle of incident. With tilt tuning, it's a big thing. So it depends on the angle that you look at it at, and the angle of the scope makes huge differences. With the lunt, it doesn't happen.
You get those Newtonian rings.
Yeah, no, the Newton rings are something else. The Newton rings is if you have two flat surfaces optically coming together. Not touching, but just in parallel. That's where Newton rings come in.
Okay. So lunt don't suffer over those either.
Yeah.
So just training for the pressure tuning.
Yeah. Like I said, 9 times out of 10, it just, if you get that weird sweet spot, we'll call it, it's to do with the tuner on the inside. The pressure needs to be released, and then you build it back up. Otherwise, you get all sorts of weird problems.
Thank you, Simon. That's
awesome.
Gold. Gold for me.
Yeah, no problem. That's what I'm here for.
It helps me a lot. So I now know what to look after.
Yes. Perfect.
Good. Thanks, Simon. Thanks.
All right. I'm going to go turn the AC on before my cat screams at me anymore.
Yeah.
Okay, Simon.
Right, Simon, thank you, man.
Okay,
See you,
guys.
Right. Good night, everyone.
Thank you, Simon.
Buenas noches.
I will first share my absolutely first image of Jupiter.
Okay.
And this is with DSLR and 300 millimeters lens, but I think it's about 210 millimeter on there. But this is my absolutely first image from Jupiter. And you can see the moons.
Oh, yeah. Yeah,
And
I was
this-
outside looking at it myself.
Yeah, you can see that is just taken in panic.
In panic.
Yes, it was. I was running after my small tripod and camera, and before it goes, you can see the tree lines here before it goes behind the trees. But I got some with my 8-inch.
When did you get these pictures?
This was the 25th Sunday.
Oh. Okay,
5 inches. Sorry,
Wow.
no 8 inches.
The red spot?
Pekka.
This is 8-inch.
8 inches.
Just, but you can see a little bit of the red, yeah. And then I took one overexposed. You can see 3 of moons. There is one. I think this is Io, Callisto, and or Europe. But I think 2 is no. It is one is behind. Yeah, I think. Let's see what I have written in my Facebook. This is Europa and Canimedes, and then Io here. So this is my second try to Jupiter.
Great.
And
detail.
Yeah, it's very low. It's 18 degrees from horizon. And it was, and I have only spot about 20 degrees in azimuthal. And I thought that the minimum height was 25 degrees altitude. But when I saw it and looked it on the stellarium, I noticed, my God, it's 18 degrees. So So on 1 second, I got 7 degrees more space I know I can reach. So I know now that I can reach down to 15 degrees. So my whole planning just okay, now we have more space to cover. And I got some picture also from sun, and you can see that as we talked with Simon, you have this brighten area, and I didn't know that I have to let it tune in so long before you shut on the moon, and some detail.
Yes,
that's what I got from this week. But now I know that I have to tune it better, and now we have cloudy for 1 week. So you get to pay.
Pekka, cloudy for a week.
Yes, you get to pay.
Did you rotate with Winchupos, or it's only single?
No, it's just 2.5 minute AVI and Auxerre and stacked. So I just wanted to test my 8-inch and it
because doing obviously in the single picture, when you stack them, you in this case has a lot of information, but I think where you're going to do the rotation of only maybe 15 minutes of videos, you will give more information and more details with that scope. I think you can
use Winchupos on that.
Yes,
but the pictures, Pekka, is a video and stacked with Registacks, or is a single picture?
No, it's with auto stacked first.
Stacked, yeah.
And then
because the details are impossible in a single picture.
Yeah.
No, I imagine.
But I felt when I was imaging Jupiter, I felt immediately that okay, this is not gonna be imaging. This is gonna be me and my scope united and taking all that because I thought that okay, this light has started, these photons has started from sun, traveled past me to the Jupiter, and just beside me to the Jupiter, and then bounce it back into my small sensor in my camera, and I can look it in my screen at that very moment. And I felt that okay, that is what my scope delivers to me and my camera sensor, that those photons has traveled first from
you try to connect it spiritually and astronomically
and mechanically.
Yes.
This is Pekka's path. That's what.
Yes.
Pekka's path. So, yeah.
I got all those three unite together and deliver something for my eyes to look and forevering that moment. And I was like, my God, I am watching Jupiter that far away in space, and that ball is just floating there, unknown that I am watching it and taking.
I saw obviously last night, not this night because it's very cloudy, but the another night I saw obviously Saturn, Jupiter, and then the moon, and I tried to do it like a 3D map. Okay, I'm here, but this is the moon, but I'm trying to be in Jupiter and then Saturn, and you
got that feeling,
start to realize that you are handling the solar system with your mind.
Yes. That's Max. Then you get in my word how I think. When you can get your feet from above, from Earth surface, and you are there with them, but your camera is doing the work for you. And
exactly.
Now you can get that moment of real astronomy. For me, we are 1,000 and we are 10,000 astronomers, and everyone feel their own way. But if you can give a hint how to prepare you for that moment, I hope I can help somebody to get that floating feeling that you are with them there.
And sometimes when obviously today I'm doing astrophotography, and I also I love to take pictures, to find some places, but sometimes you need to put out that and try to see with your own eyes what you're trying to capture, because
I couldn't agree more. That's important.
Yes, absolutely.
It connects you with the nature, and the deep space. Obviously, you're not going to see it like in the picture, but it's in there.
Yes.
So knowing what you take and knowing what you are seeing, that's a very important connection with the astronomy.
Yes.
And obviously with the planets, seeing another planets, giant planets, also with the moons passing by.
Absolutely.
Today I saw, I think it was the first image of, I think it was Uranus, and a moon passing by, projecting the shadow in the surface. I think it was, no sé si la conoces a Lori Rachich, Cesar.
Lori Rachich, sí, yes.
Sí. She posted that image. I don't know if it was from the Hubble telescope, but it's an impressive image, because obviously you see in Jupiter passing by Callisto, Io, Europa,
yes, but
projecting
never another planet.
Obviously, Saturn. Well, it happened in some years, but in these giant planets that they are very far away from us, it still happens. So
yes,
that's another thing with the thematic of today of the GSP, of what's around us and what's beyond.
Yeah, I realized the one problem. I talked with my astro friend here in Stockholm and with the go-to mounts. If you don't have really good go-to alignment, you are going to rule your evening to get with those big scopes, Celestron 8-inch, because the focal length is so. If you are
try to find something now,
find something and get that on the focus, because I have the focus motor also. I'm gonna ruin the whole night to find that target, to get focus, and then begin to shoot. Instead, I don't take the scope, or I leave the scope, get my binoculars and watch with them, and enjoy instead. That ruin my whole night to get focused and find that target. So I will that go-to alignment, that it's spot on for next season, and then just park my mount, and I know that the go-to alignment is perfect for visual work, because it's gonna take lots of hours in light polluted skies I have. I'm gonna not find anything to align it with. And I don't know if that's a correct star even. So I have to make it very early in autumn, when I have only Arcturus, like Vega and those bright stars. So I know that, okay, that is 100% sure Arcturus. And then save the alignment. And now I know that, okay, I can take fainter objects But otherwise, I get crazy. I'm just like spoiling my whole night. And that's why I got my hair shorter so I cannot rip it off.
Oh, geez.
I get wooden sticks when I am. What is this? I get sticks under my nails, scratching my head. My head.
Yes. Well, gentlemen, it is now midnight. Okay, here.
Yes.
And
Yes, I'm here
so
to.
I think and some of the audience is already starting to fall asleep.
Yes.
Yeah.
But they got the good night stories.
Is that where they are? Yeah.
Oh,
that's
yeah.
great
Good after
stories
party
tonight.
stories.
Yes.
Keep energy for the next safari.
Yes.
Yeah.
Absolutely.
Right.
Absolutely.
That's right.
You have the time for the next, Scott?
Well, I don't have the theme yet. No, I usually what I do is after I finish the star party, I then think about, okay, what's going on?
Yeah.
I read the, some of the newer advances in astronomy, and I try to get a theme based off of that,
How to unite with your scope.
What's that?
How to unite with your scope.
How to unite with your telescope. That's true. Well, Jerry Hubbell and I always talk about making the equipment disappear, because it's you and the universe.
Exactly.
And this is what you're talking about.
That is the thing, Scott.
All your equipment is working correctly.
Yes.
And it's muscle memory, and how the instrument works.
Yes.
Then
you get that feeling.
It's like a musician with their instrument,
you are united
with their violin. The violin disappears and the music is everything.
Exactly.
Right?
You are united with your telescope.
Yes.
That disappears, like you said.
Right.
You are just seeing that the telescope is somewhere there, but you don't know where. You just see the thing in the front of you, and that's 3D.
That's right.
You are there, and the telescope helps you with that. Therefore, I just need to unite it with my mount, and therefore I get those calls, when your hair is rising.
Yes.
And when you go on the balcony and you unwrap the cover and you see it, okay, my pal, you are going to work for me tonight.
That's great.
Yes.
Well, Maxi, Cesar, and Cameron, thank you very much. For any of the presenters that are still watching, thank you for participating in the 56th Global Star Party, and for the audience that all their great comments and questions and camaraderie. It's the combination, it's the culmination of all this that make Global Star Party what it is. And someone paid me a very nice compliment earlier, but I can't take credit for it. I know that it is the combination of the audience and the presenters and our shared vision and love for the sky that make it all happen. So it's just nice to be part of it.
But Scott, you have made already a whole new kind of, not institute, but you have made one kind of lifestyle. You have made something
that was forced on us because of the pandemic.
Yeah, but now you have a style that we all know. Okay.
Yeah.
That time is ES time that we are going to share, and we know the rules. We know how it works.
Yeah, you know how it works. That's right.
Yeah, and we know everybody knows that. Okay, we're gonna get this from this evening, and then I'm happy the rest of the week.
Yeah, thank you, man. Thank you.
Yes.
Well, it is, it's the only way to have a global star party. You know,
Yeah.
we have to get online together. And
You are like Link. You are uniting us
well,
all around the world. Me sitting
Exactly.
in Stockholm, Cesar in Buenos Aires, Cameron in, let's see if I remember, it's
Seattle.
he's in
Seattle.
Seattle. That's right.
Yeah.
That's right. We
West-
have
Maxi
people
West
from
Coast.
United Emirates watching. We've had people from Egypt watching.
Yeah.
You know, it is a global audience, a global participation kind of thing, and
It's so fantastic. And
it's
all we
wonderful.
share the same sky, even. So that's kind of weird thing, but different time.
Mm-hmm.
So when sun rises here, it sets for you, but the same.
Right.
The same. Yeah. Sometimes when I see that it sets, so I think, okay, now it's rising for you.
Thank you.
Thank you.
But I think, okay, take care of it, because you are going to send it me next evening.
That's
So I'm
right.
looking for the rising. Okay,
Well,
thank you, Scott.
Tomorrow we'll be back with Cameron Gillis for more Camstronomy, and we have more programming all the way through Friday, and then back to the next Global Star Party. I do want to announce that we may be taking about 1 week off, okay, because I have to make a trip. So,
whoa,
yeah, Scott has to make a trip. So
you need to eat.
So
Yes,
I
you
would.
You deserve it.
Gone for about a week. Thank you.
Are you going to do you come into Europe? Don't you?
I have before, but not this time. Not this time.
Okay, because you told that you have been in Hungary, or it was in.
I've been to Spain. I've been to England. I've been to Germany, Amsterdam.
Didn't you plan that trip to?
Yerevan, Armenia.
Yeah, Armenia.
That hasn't happened yet.
We are going to Armenia for the
Yeah,
Star
that
Wars.
happens next
Yes.
September. Not this year.
Okay,
September,
2020.
but
Yeah.
2022.
2022.
That's called the Starmus Conference, and
Yeah.
so yeah,
It
anybody
was
that wants
those
to.
guys who renovated the old observatorium, wasn't
Yeah.
it? They,
Yeah, I have.
wasn't
We
it?
are challenged by having a giant star party there with thousands and thousands of people.
Yeah. Wasn't it that town that they renovated the old observatorium that was closed and something like that in the city in Romania or Hungary? There was an old observatory in the city and they renovated it.
Oh, they did.
I think it was in one star party for long time ago, last spring.
Hungarian. Let's see if we can find it here real quick.
It was a concrete building and it was falling down already, and they took over it from the government of the city and they began to renovate it with funded money.
In Romania.
Yeah.
In Romania, huh?
Yeah.
Romania.
He was on the star party.
Yes, I don't doubt that. The Admiral Vasil Ursanau Observatory.
And they should have a
And
star
then there's
party.
the Astronomical Institute of Romanian Academy, but I don't know if that was. I can't remember.
No, it was a long time
I can't
ago.
remember.
I just remember that you told that
I'll wake up in the middle of the night going, it's so. I'll call Pekka, hey.
But anyhow, if somebody of you are going to come to Scandinavia, I'm happy to show you around.
Oh, I would love that.
Yeah,
I would love that.
there is
Yeah.
so much places that will not be shown to tourists. That is absolutely something to see, because they have their roots, and everybody sees that, but there are so much more to see. So,
yeah, and we love Pekka. We love the in Argentina, sorry, it's the people is amazed with the all TV series and Netflix that are from your country, Sweden, Sweden, all the from the north, and maybe in the United States the same, because the success of the Sweden TV series from Police or come on, we are amazed.
I think you have seen the Beck movies.
Sorgen or the books Millennium series are all about the culture. It's in Argentina, the opposite. All people say, which series? Yes, I watched the series from Sweden.
No, okay. Okay. And I admire the United States of America, the South America. We just want to go there, and we don't care about Sweden at all, or Finland.
Really?
Okay. Here is nothing. Boring.
That's not true. It's not true.
No,
to go to Sweden
us,
is the dream of many people, So.
Yeah, I know. Yeah, I know. There is benefits here also, but sometimes some picture is too small, so you get to get. Because the weather here.
Yes, I understand, but you
can do astronomy in the middle of the night in winter time. It's still warm. It's like 10 degrees Celsius in January.
I understand.
And the night comes without twilight. Night and day is like boom bang.
Done.
Yeah. And here we have a twilight. We have a dark. Then comes the environmental night, and then comes the astronomical night. That's only a couple of hours.
I think in that time when you do astrophotography, you don't need a cooler camera.
No,
but you have this boundary. You have day and then bang, it's night.
yeah, absolutely.
And we don't have that. We have in summertime up north, the sun never goes down. It just bounces on the horizon and up again. And wintertime, maybe 90 days, or not 90, but 60 days, the sun never rises above horizon. It's dark all day, 24 hours night.
Wow.
Yeah. In up north, it's like that. And summertime, sun never goes. I have seen once we was on the lake and it was very calm. The sun gets down and just touches the horizon and then up again.
And then back up?
Yes.
Yes, it's grail.
Yes.
Like here in Antarctica.
Oh my gosh.
Yeah. That's
something you don't even realize when.
So how do you sleep? I mean,
it's problem.
Is it difficult to sleep when?
I think that makes it different because the human has its own melatonin system, and that they have problems with those. We can see because those who lives up north, they are very much smaller people than we are here in south. In growth, and that has to be with melatonin levels to do because they are like 160, all of them. They are shorter than we. In up north people. So it has to be something with melatonin cycles.
Oh, the melatonin. Oh,
yeah, sure. It have the same problem people here in Ushuaia or Santa Cruz that. No, it's not so strong, the difference, but you have maybe that at 11 p.m. that you can see the sun.
Yeah, but they are more healthy. They have longer lifetime, and then we have here. They live close to nature all the time. They are outside almost more than 70% of their time. So they are more healthy up north and we here in south.
Sure.
So they are very close to nature. So I want to see the auroras also. I have seen
Yes.
those. I have seen those once in my lifetime. Milky Way, never. I'm not going to
Never?
US.
Oh.
Never. I want to come to US and see the
Yeah,
Milky Way.
in the United
Yeah,
States,
yeah.
we'll make sure that you see
Yeah.
the Milky Way.
Yeah.
Yeah.
I have to send my gears in advance with container ship.
Right. Yeah. Well, we have in 2022. I've talked about it several times, but we have the Arizona Dark Sky Star Party.
Yeah.
It's a nice dark sky site about maybe an hour and a half south of Tucson. You know.
I will be there. If,
Yeah,
if
it'll be
not
a
before.
great star party.
If not before, Scott.
If not before, okay, all right.
Yes.
Well, you're
yes.
welcome. You're welcome.
Yeah. Thank
So,
you. Thank you.
all right. Okay, gentlemen. Well, we will call it a night. Thank you so much. And,
Yeah. Thank you, Scott.
And to the audience,
Thank
keep
you,
looking up,
Scott.
as my old friend Jack Horkheimer used to say.
Yeah.
So, yeah. Take
I
care.
need that scope on your desk.
Yes.
Okay. Bye, Scott.
Bye-bye. Good night.
Bye, Cesar. Bye,
Good
Maxi.
night. Bye,
Good night.
Pekka. Bye, Maxi. Bye, Cameron.
And Scott, everyone, awesome.
Good night.